Hey there, you know I love the sound of that music when it starts because it means it's another SkyTour LiveStream here on this first day of October 1 and 2, 2017, from the John Zach Memorial Observatory in northwestern Connecticut. It's a nice night. We have a waxing gibbous moon, which means it's increasing in size, and we're going to see clusters tonight and many stars. So we're going to see globular clusters and open clusters, and we're going to check them all out in due time. Now, as you know, you can participate from the chat. You can give me options to look at some things, and Amanda is going to ask you some chat questions, so we'll see you in a minute. Hey there guys, hello and welcome to tonight's SkyTour Livestream. I'm your host, you know, the ever-present Mark D'Antonio, and we also have Amanda hiding in the background. Hello Amanda.
Hi Mark, hey Al. Hope everyone's having a nice weekend.
Yeah, I'm sure it's going to be beautiful. We're looking at the
moon looks beautiful so far.
Oh, isn't it beautiful?
It is.
Yeah, we're seeing the moon right here. We actually have up in the upper right-hand corner, we have Plato. That's a 60-mile diameter crater. And you'll notice it has a flat bottom. It's kind of an interesting crater because all of the near-side craters have these flat bottoms in the cases where you have this dark maria that shows up. That's the lava, of course. And that dark maria is something that is very, very important, because it shows us how, in part, the moon was made, when it was made. Because, and I don't mean artificially, of course, it shows how the mechanics of the building of this moon occurred. Because on the far side, we have no such maria at all. It's kind of cool. So I wonder if everybody even knows why the far side of the moon, the side we don't see, is actually more pockmarked with craters than the near side. And that's something that I've always wondered, and science is sort of catching up now. We think now that in the early stages of the formation of the moon, the Earth was still molten, and the moon was partially molten, so they were both partially molten. And the infrared energy coming from the Earth actually had a fairly high impact on the molten particles and molten debris that was being shot off the moon from impacts on this near side. And when that happened, what would happen typically is they would be set into motion by the radiation pressure of this infrared radiation coming from the Earth side, and it would tend to send the particles to the other side of the moon, where they would cool and settle. So over time, over billions of years, the far side of the moon became a little bit thicker than the near side. So the near side crust is thinner, of course, and then when anything hit on the near side, it would tend to basically bloody the moon, make it bleed, but of course bleeding molten lava, onto its surface where it would spread out and finally cool. Now the surface of the moon is basically, even in the maria here, you'd be hard-pressed to find an actual exposed rock. Now, we've seen the Apollo astronauts touching rocks when they're on the moon. But guess what? Those rocks are covered with a thick layer of dust. That is lunar soil that's been pulverized and settled on those rocks from other sources. So that happened over a long period of time. And that's something that actually was due to all the many impacts hitting the moon, all the dust that got shot up around the moon from those impacts, and that stuff would just settle back down wherever it may on the moon. We also notice that on some areas where there's craters that you can, see down to the tiniest detail, like those that you see on the Lunar Reconnaissance Orbiter imagery, you can actually see that most of the craters, are actually filled with debris and having like this exorbitant amount of debris in their bottoms. And you have to say, wow, that's pretty cool. How did that happen? Well, the way that happened was that all the many impacts would shoot dust into the air and regolith, that is a lunar soil, and then it would come back down. And it would land, wherever it wanted to. And again, some of it would land in some of these other craters. The other thing is that as the impactors hit the moon, it caused moonquakes. And just like if you stomp your feet near an anthill in your yard, you can make the dirt at the top of the anthill topple off the anthill because of the vibration. So think of that as a billion times more intense at a much higher scale, and you get what happens with these little craters. They fill because the moon quakes and the vibration just causes this stuff to drift down into the crater from the edges. And with a young crater, they're very sharp edges, so it doesn't take much to dislodge stuff at the edge of the crater and knock it down into the center. And we actually see on the Lunar Reconnaissance Orbiter imagery, which you can look at if you go to the Lunar Reconnaissance Orbiter website, which is LROC, and then look up Quick Map. Okay, so look up in Google LROC Quick Map. I did a sky tour of that very thing, actually, on a cloudy night stream to actually show how to use the Quick Map. And we're going to get into it again at some point to show some more details, some more stuff that's really cool in there. And what you can do when you go in there is you can see the craters that actually failed. That is, where there is, they call it, now the actual term for it is where the edge of the crater collapses into the center of the crater. That's called slope failure. I mean, makes sense, right? It's a slope failure. So, but you see gullies, and you see that are carved by debris and avalanche falling down into the crater. Of course, it's at 1/6 the gravity of the Earth, and so it happened a lot slower for sure, but it's pretty cool. Now, the craters themselves obviously vary in size. We talked about this on P&K Space Imaging, another one of my favorite places to go. It's a haunt of mine, as many of you know. And we've talked about the fact that the craters sometimes are just simple craters, which look like little bowls, like a cereal bowl gouged out of the moon. And I did a TV show called Aliens on the Moon where they tried to tell me to tell you all that those little bowl-shaped craters were actually radar dishes put in place by alien races. And you know what? I just couldn't bring myself to sit there and be disingenuous to all of you. I just couldn't do it. So I told him the truth, and I think that's kind of why he, the producer, decided that he was going to cut off a lot of my responses to him, because I'd say things like, "Oh, wow, that looks pretty interesting, but I think that it was formed this way, and I can show you because I actually created an experiment to show you how that could have happened." They didn't want to hear anything beyond the, "Well, that looks pretty interesting," and that's so on that show. It looks like that's all I'm doing is saying, "Wow, this is really interesting." At least I didn't watch the whole thing. I got disgusted after 10 minutes. But later on, James Oberg, who's a former NASA guy, Jim calls me and he says, "Haha, you were that red shirt guy from Star Trek," which is, of course, the red shirt. You look down, you see you're wearing a red shirt when Captain Kirk tells you you're going on a landing party, and you go, "Oh man, I'm gonna die," because always the red shirt gets killed. So I felt like the red shirt guy, and Jim said, "Yeah, you're a red shirt, haha," and we had a laugh about it. So I gotta say, that you can't win them all. But with the moon, it's pretty simple to me. Okay. We have these bowl-shaped complex, simple craters, and we have these more complex craters. Okay, complex craters are craters. Let me go and show one if I can. We're looking at the moon right now. Let's go take a look at the moon here and move over. Okay, go near the terminator. Okay, and let's see. Oh, that's really cool, actually. Well, see, near the terminator, we can't really see what's in the crater, and what makes a complex crater something to look at over a simple crater is that a complex crater actually has a central uplift, like the crater Copernicus. It has a central peak in the middle of the crater, and those are complex craters. Okay. Now, I'm zoomed as far as I can go here, so I believe that's actually a complex crater I'm looking at. It's kind of difficult to tell, but all right. Well, okay, this is obvious. Okay. All right, now there we see a pair of complex craters. You can see the central uplift in that crater, and you can also see just above it there's also a crater that has a central peak as well. Now it has something to do with the size, but it also has to do with the impact energy. If the meteor struck the moon at 10 miles an hour, then it wouldn't create such a spectacle. It would only create a hole that's just a little bit larger than itself. But as the energy increases, the diameter of that impact also increases. And the formula for that I actually have in a program I wrote to actually show you how that works. And I got it from a paper by Jay Malash, who actually calculated asteroid impact sizes and craters, the resulting craters from such impactors, and it took into account the density of the impactor, and the size and the speed and the angle at which it hits. So that's what's interesting. Now, one of the questions that I've asked over in P&K is, why are most of the craters round? And they do seem to be, don't they? Well, most of the craters are round because of the fact that the impact energy is such that at most of the angles at which an object can hit the moon, that energy, the way it's dissipated, is such that the energy ends up going out spherically in all directions from the impact. And so that tends to excavate a round hole. But there are places on the moon where we don't see round craters. In fact, we actually see skip craters. Craters where objects hit and they ended up striking again nearby. And I'm not sure if I can. I don't know if I have the resolution. The moon is fairly high in the sky, but I might have to. I don't have the focus set that it can do it, I don't think. But I'm trying to show you one such skip crater, but it's actually a really smaller feature. In any case, the crater I'm looking for is Messier, named after Charles Messier, who was the famous the purveyor of the famous catalog of anomalies that were not to be mistaken for comets. He was a big comet hunter, as you know. We've talked about it, and he would always try to find a comet in the sky, and then if he saw that it wasn't the comet, he would actually look at it as a object to avoid, Now, it's not that he didn't enjoy these objects. He had a specific mission in mind. He was actually trying to find, specifically comets, but he wasn't trying to find, planetary nebulae or globular clusters. But that's the kind of thing that he actually did end up finding, and that's good. I'm glad he did, I just did that because I want to try and reduce a little of that glare. Yeah. When you look at the moon when it's near full, you don't have any real contrast from shadows, and that's why everybody loves to go over here and look at the terminator, because that's where the shadows are, because you see the moon as the objects are just being illuminated, and then when you come up top here, you can see that some of the crater rims, like this one, are just on the fringe of being illuminated, and just that far side is illuminated. But again, as it continues to go around the sun, more of it will become illuminated, and so that's actually pretty cool. I've always enjoyed that. And as a kid, I tried to work out the physics without knowing what the word physics was. I tried to work out the word to tell me exactly how the moon could be lit like it was. And one of the things that even adults have a problem with is when you look at this moon. Okay, let's go back to see the whole moon. When you look at this moon, nowadays, when we look at it, most people can look at this and say, oh, that's a sphere that's partially lit by the sun. And you say, well, yeah, it's partially lit as seen from the Earth. But the whole thing, okay, the light is falling on the side we can't see as well. So we don't see that side. But at any one time, except during an eclipse, half of the moon is illuminated at all times. So it's kind of weird to think of it, but on the other side of the moon here is an illuminated side. That's the far side. So when people call it the, quote, dark side, unquote, it's really not dark. It's never always fully dark, except when it's a full moon here. So that's in the same way that we're seeing an increased size, the other side is seeing a decreased size, illuminated portion. So that's pretty cool. That's neat to think about and talk about. I like, discussing the moon. And what's funny is when you look at this moon and you just look at it the way it is just now, look at the contrast between the darker areas and the lighter areas. Now, we're seeing this in color, okay? But you say, well, what about the color? What is the color of the moon? Well, they did a study. In fact, it was the famous Lunar Reconnaissance Orbiter, the LRO that I always talk about. Excuse me. And the LRO found that the colors of the moon do have a variation that's not just gray. Okay, there's white, there's off-white, there's gray, of course. There's light gray, dark gray, as you can see in this image. But there's also browns. The moon has a lot of browns. And that's something that's very interesting, too. So, compositionally, when you look at it, you say, well, how does the moon compare to the Earth? And the answer is that the moon is almost identical to the Earth in composition, believe it or not. The moon's composition chemically is like us. And you know what? You say, oh, well, that's great. That makes sense. So that makes sense that the moon could have come from the Earth, in an impact with the Earth. Or an impact, something impacted the Earth and created the moon. And that's the prevailing theory. But guess what? There's a problem with that theory. The problem with that theory is that this moon here that we're seeing doesn't show anything that indicates the other impactor that might have caused it. You see, you would expect it to be a blend of the two. It would be a blend of the Earth and a blend of the object that hit the Earth to cause it. Because that object was certainly annihilated and melted and thrown into its components and elements. But clearly the moon is not that composition. The moon is not multiple compositions. It's almost too much like the Earth to have come from the Earth. Isn't that crazy? To have come from an impact. Because we would have expected to see this impact evidence, So that's my nightly monologue, and we spent it on the moon. Amanda, how are you tonight?
I'm well. I liked listening to that, but I, of course, have a few questions, and I'm sure some of them have been asked to death, but
that's okay.
I'm gonna go ahead and ask anyway.
I answered to death, so it's okay. Okay.
Okay, like when you're talking about the entire moon always being lit up from the sun, it's just we can only see one side.
Well, half of the moon's lit up, yes, at any one time in general, besides it being in an eclipse, yep.
Yeah. So, like, say something like, and again, I might mess this up, but like something like Apollo 13.
Yep.
When they had to, didn't the only way they could get back was to like kind of flip around the moon and kind of like slingshot back?
Well, yeah, they were already on their way to the moon when the oxygen tank exploded in the service module. So they actually had to continue to the moon and then circle the moon one time. I don't remember if it's just one time or several times, and then set up for a trans-Earth, orbit, and to send them back to the Earth. And that was the that indeed was, very harrowing. I was riveted to the TV when that was on. They always had these special reports, and I could only just imagine what these astronauts were doing, fighting for their lives.
What year was that? You were watching that live?
I did. I watched the moon landing live as well, 1969. I was 9 years old. Yeah, I'm 56. I was born in 1960. And so...
I know, but...
Apollo 13 came along.
When you think that long... Well, I mean, I don't remember, big events on television when I was 9, but then again, nothing that remarkable has really happened in my lifetime, but... Not like landing on the moon or...
Oh, are you serious? What do you mean nothing remarkable has happened in your lifetime? Are you kidding me?
Something to watch on television?
Well, how about
9/11.
This? Something, yeah.
Basically.
Okay. Something that the press would cover, all right? Yeah, a terrorist attack is something the press would cover. But, for instance, the L-Cross mission where they sent a booster down into a crater... was it Cabeus, right, on the south pole of the moon, which I actually looked at, and I can actually create that as a 3D model. We're going to talk about that in a minute. But as a 3D model, that crater is interesting because some of it is actually in perpetual darkness. So that means that the moon never has any light hitting certain parts of it. And it's in that darkness, that forever darkness, where we figured there might be some ice, trapped water. And sure enough, we were right. And when it's called the L-Cross, L-C-R-O-S-S, the L-Cross mission used this expended booster, and it slammed it into the moon in that crater. And the spectrum, when they looked at the light coming back from the explosion and the actual dust that was thrown up, the material thrown up, they could deduce the elements in it through spectral analysis. And by doing so, they discovered that there was water in that plume of ejecta thrown up by the booster impact. That's something that's very important too, because if we're going to have a moon base, well, what do we need on the moon? We need to have water, don't we? We have to have some water. We have to have a way of getting water. And that's something that's few and far between us and the moon. But on the moon, there's some there, and on the Earth, of course, there's plenty. Then if we have to go out to Mars, we have it locked up rock hard as granite in the North Pole and South Pole of Mars, along with the dry ice, that is the carbon dioxide ices as well. And then we have Enceladus at Saturn, we have Europa at Jupiter. There's water almost everywhere we look, and in almost all the atmospheres. So it's interesting to think about that. Even Pluto has copious amounts of water. Did you know that? Even Pluto. When the New Horizons spacecraft sent back the imagery and the spectral data, it showed that there are certain outcrops on Pluto that actually have, they're made almost 100% water. Now, granted, the white part of Pluto is predominantly nitrogen ice, okay, because the nitrogen would freeze out, obviously, and so that's what Pluto is predominantly covered with. But then it has, among some craters, it also has water ice. And the water ice is actually, I believe, one of those things that they were calling snails on Pluto, because in the middle of these little tracks, you saw these little bumps sticking up. And those bumps were mountains of water ice sticking up above the nitrogen ice. It was really cool. I had to do that for a What on Earth episode, in fact. And that was used on the front page of that episode on the streaming sites and on the TV guides and so forth. I mean, a really interesting photo. So anyway, continue with what you were saying, because I apologize for immediately dominating after you were trying to ask a question.
No, that's okay. No, those ice snails or whatever you want to call them, that's cool.
Yeah.
We can talk more about that too. See, that's the thing. You say so many interesting things, and I have like several questions for each point that I forget half of them. And
that's okay. I sometimes go off on tangents too, and I wish I didn't go off on so many tangents. It would be easier for people listening to me. But what can I say? I'm surrounded by all this wonderful equipment. I've got all kinds of wonderful things to show and explore, and it's like and just wait till winter is fully here, and if I'm still able to move my bones, I will be out here to show you some of the greatest winter sights, because there are nebula in the winter that show up like unbelievably well. Of course, we know the Orion Nebula, but we also have the Running Man Nebula. We have other nebulae. We have the Orion Loop, which we'll try to take with the camera on wide angle. There's just so many things to do. And then there's all these planetary nebula, open clusters, globular clusters, and other wonderful things to look at, all in the Orion region. It's just so much. So continue, sorry.
Well, I'm glad you're the one going out in the cold, taking all the pictures, and I can stay nice and warm and bundled and just listen. Just listen and look.
Okay,
we appreciate it.
I'm okay with that. I'm glad. I like to do what I do. I don't have any problem with that. You know.
Well, no. Okay. Well, what I was saying about Apollo 13, if they weren't in panic mode,
yeah.
I mean, would that have been the best way to take pictures of the other side of the moon? I mean, I guess satellites go? Do satellites go all the way around the moon?
Yeah, that's actually a good question. Yep. If you go to the LROC Quick Map browser, and you see the near side of the moon as the basic default image, but if you
the side that's tidally locked to Earth. Correct.
Very good.
Okay.
And then if you look at the upper right corner of that it's sort of a pull out. It's a fly out menu that shows you a bunch of layers that you can put in, and among those layers that you can use, you also have something called the far side orthographic, meaning you looking at the near side orthographic when you go into the quick map. If you want to see the far side, you just click it and bam, you got it. And then you could look at the poles if you want to. You go look at select the North Pole orthographic, the South Pole orthographic, and see Cabeus crater at the South Pole where we launched L-Cross. And then among those overlays, you can select, it's called the LRO featured images, and then little yellow dots show up all over the map that you click on, and they take you to other sites where you can actually read all about what they're talking about for that particular site. Oh, it's just stupendous and wonderful stuff. You know?
I remember the yellow dots with the names and what was it, like the dimensions on how deep they were and the diameter or something? I forget the information, but it was a really cool site. Yeah, really cool site.
If you select nomenclature, then you get all the names, and if you click on one of those, then you get information. But if you wanted to know about how deep they were, then up in the upper right hand corner you had a little toolbox, a little tool indicator, and you click it, and then you had a little icon that you click, and then you can draw a line, and it'll give you the profile of the terrain under that line. So if you draw it through a crater, okay, like Copernicus crater here in the center, okay, then you would actually get a graduated, ever deepening hole, and then the central peak and so forth. It's really, very, very well thought out. And by the way, while we're here looking at Copernicus, I just wanted to say that right about there in the center, that's actually just left of center. There is the Apollo 12 landing site, and Apollo 14 is a little bit more to the right over here. So Apollo 14 was actually very, very daring because it landed in some of the rubble ejected from the Copernicus impact. I thought that was pretty cool. So that's just right in the center is the Apollo 14 landing site, basically. So that's just neat. Thought I'd throw that in because I hadn't told you yet.
Oh, that's very cool.
It's
a very popular requested site to look at. So
sure. And of course, we can only see it, from way, way far away. We have to, come in fairly heavily and zoom very, very deeply into the image to be able to see the remnants of our human exploits there. But that's okay because, I don't have any issue with people who say, I want to be able to see the moon landings. How come we can't see the moon landing sites with the Hubble? It's so powerful. And, as I mentioned on P&K, the Hubble has a certain size image sensor to acquire photography. And the lunar lander on the moon, at this distance, okay, 240,000 miles nominally, okay, 240,000 miles or so, the lunar lander would actually appear in terms of the arc seconds that we know, okay. The lunar lander would be somewhere in the neighborhood of like 0.05 or 6 arc seconds, really, really small, very small. And the maximum resolution of the Hubble can show something that's only 0.03 arc seconds in size. That's per pixel now, per pixel. And remember, an image takes many pixels to be made because a pixel is only one color. So the entire Apollo landing site, even the biggest one, the biggest Apollo landing site, would only take up 3 or 4 pixels on the Hubble sensor. And those are, images that are a certain color. So that's the resolution of the Hubble. And it doesn't work for the moon, but it works for deep space objects because the scale there is sort of immaterial. We don't, try to zoom in beyond where it's reasonable to zoom into on these objects because they're so big and vast. Remember when we were looking at the Veil Nebula, and we're seeing how that supernova remnant just goes on and on and on? That's light years in size that we're looking at, many light years. And when you look at the moon, you're trying to look at several feet, and it just doesn't work. I wrote a Facebook post about it. And by the way, Copernicus is one of the craters we offer. We actually have, this is something that I'm doing as FX Models, my business, but if you're interested in these craters, I take this U.S. Geological Survey data from the USGS. I get the moon height maps, that is the heights of all the craters on the moon, and I can generate a 3D model from that, and I print them out on a 3D printer. Now, you can just get the straight plate, okay, or you can get these mounted on a wooden plaque with a brass plate with the name of the feature and the latitude and longitude on the moon of the feature. And those are this goes with our planetary replicas division and what we're doing there. And look, I'm not going to turn SkyTour LiveStream into some type of profit center. That's not what this is all about. I'm just saying that for a nominal cost, if you want to have a nice, very nice image of the lunar surface that's solid, that you can hold up to the light and angle it to see how the light falls across the terrain, it's just so beautiful. Or if you just want it because it's your favorite crater, like a lot of people want Aristarchus, a lot of people want Copernicus because of the rays, and we painstakingly paint all the rays that you like you see all the rays emanating from the crater here, all this ejecta. We paint that in, we put that in. You see it, and it's not exact, okay, because we do want to offer these for a reasonable price. We don't want to make it something that is like a National Geographic quality, because we'd have to charge National Geographic type prices, and that'd be crazy. I'll just give you something that's nice and fun to use and to take with you to do. If you do any talks of yours on your own, that would be fantastic. You can do it. So anyway, I just thought it would be kind of cool if you wanted to do that. So we have, if you have a favorite crater, you just tell us what it is, and we'll gladly show it to you, and we'll see if we can print it. I love that stuff. So anyway, okay, enough of that. If anyone has any questions, let me know.
We do, actually.
All right.
We actually have one from our good friend Tana. She made it in. She said she sometimes listens but doesn't chat all the time. And she said next time you stream, let her know because she had a question. Give me 1 second. Okay, I just got it here. Okay. Can you spot the laser tracking system they left on the moon? It's said to ping back a laser light that shows where it is on the moon, but can only be seen under certain types of lights or filters, not detectable with the naked human eye.
Well, yeah, the reason that's all of that is relatively true, and I'll tell you why, Tana. The retroreflector, it's called a retroreflector. The reason that it does what it does is because the reflectors are a special type of reflector called a corner reflector. Same as on the taillights of your cars. If your car is off and you shine a light at your car from the side, you still see the taillight light up. If you shine it from the back, it lights up. That is to say, it reflects light brightly. Then you go to the side again, and the other side, and it does it again. That's because no matter what angle the light hits that reflector at, some light is going to come back to you, no matter what you do. Now, why do I know about this? I know about this because where I got my astronomy degree, my university created those retroreflectors. And there's actually an actual model of them, or actually a real one, a duplicate, unused, unflown version, sitting in a glass case there. And I always look at it, and there's like a simulated lunar terrain. It's really nice at the university. And so, it was the university engineering division actually built that in the university shop, which is very, very complete and very good. So yeah, the reason we don't see them though is because if you send a tight beam, like of an argon laser, which is green, up to the moon. And why green? Well, we send green because green light can actually penetrate most of the atmosphere the easiest, and we stand a good chance of seeing it on the way back too, because it'll penetrate the atmosphere again coming back. Basically, it has a good window in the atmosphere to penetrate out and back. So they send up a laser like that, and by the time this laser beam gets to the moon, it's not going to be a little pinpoint. It's going to be miles in diameter, because it diverges, and then that little bit of that light is going to hit the reflector, and then an even smaller part of that's going to come back to the Earth, penetrate the atmosphere. Some's going to get lost, so you don't have a hope of ever seeing the reflection directly, and what comes back is going to be several miles more wide. And so you have to have a sensitive detector that can detect it, and this reflection comes back in just over a second. And it was put there on the moon specifically to be used to give us the distance to the moon accurately, month to month, year to year. And we see that the moon is actually leaving us. It's actually spiraling slowly away from the Earth to the tune of about 2 centimeters a year. So you can figure, well, at 2 centimeters a year, how far will it be in a million years? Do the math, figure it out. What are 2 million centimeters in miles, So, it's like, you get an idea. Now, the thing is, the moon, that spiraling feature of the moon, you got to compare that to how long the sun is going to last, which is another 5 billion years, and see if, the moon's distance would be of any consequence to human life at that point, 2 million years from now. They can see how it is, or see how long it will take for the moon to actually then be able to break free of our gravity and be on its own. That means our tides would be reducing little by little, over the millennia and centuries and eras, epochs, and then it would eventually basically have minimal tides. As the moon left, the only tides we'd have are from the sun. Because that's actually the other reason that we actually have tides, is because of the sun. Now, when the moon and the sun are on the same side, then we have an extraordinarily larger tidal bulge, and when the moon and the sun are opposite each other, like at full moon, then we have a different tidal bulge setup, because they're additive when the moon is on the side toward the sun, and they're also additive when the moon is on the far side, believe it or not. So there's actually it's a fairly interesting bit of physics for why that all happens. But understanding how the forces work on the Earth would tell you how that all works. So I hope that answers that, Tana. But the bottom line is that light coming back would be so minute that you really do need a highly sensitive detector to detect it.
Well, well, we can't see the light coming back. Can we see it? Can we see
signal?
The reflector?
No, the retroreflector was only approximately 3 feet by 2.5 feet wide. It was very small. But you don't need much when you're sending up a laser beam that can be detected with sensitive equipment. So.
Yeah, I like the synchronicity. It just so happens to be the university you went to. Oh, that's pretty funny.
Yep. Yeah, the Apollo retroreflector program was they were built at my university.
Yeah, that's very, very cool.
Hey, it would be great if I could say, and I built them, but
well, I was going to say it was probably done and up there long before you ever attended, so.
Yeah, I was 9 years old when those were actually made.
Oh, was it brought up with the first moon landing?
I saw the first moon landing live on television.
I know. Is that when the reflector was brought up, though?
I'm not sure if they put the retroreflector up on that mission or not. I'd have to look.
I thought you said you were 9 when this happened as well.
No, I'm just saying I was 9 when the moon landing occurred. So, and then they came fast and furious one after the other.
I don't know. This could have been put up in the 80s. I don't know. I don't know anything about it.
Well, it could only have been put up in the era of Apollo, from Apollo, from Apollo 1 failed all the way to 17.
That's crazy. Actually, there was talk. There was another question coming in, but beforehand, there was talk about Elon Musk.
Okay.
Did you see him in the news recently?
Well, for which story?
Well, I wasn't sure. It was a comment from Rocket Man, actually, not that one. And he said, "Did you hear Elon Musk talk the other day?" And I said, "No. What did he say?" And he said that you'd be able to board the BFR in New York and land them in Shanghai in under 40 minutes, and that they'll be launching 2 of them in 2022 and 4 more in 2024.
Wow. So
2 of which will be manned.
Big effing rocket?
I don't know. But then Andy commented that SpaceX reckons they'll be off to Mars in about 5 years' time. And I've heard that. I heard he had to, whatever it was called, the whatever Mars orbiter or whatever, he actually tweeted out a while ago, about a year ago, he had to change the name because from what he has worked out, he thinks he'll actually be able to get a lot further than Mars in the same amount of time he was originally hoping for. So
I think that's great. I'd love to see that happen.
It could be like a multi-planetary orbiter. So
I like that idea.
I don't know. I think that's pretty cool. I think he's really funny. I think, you know what I mean? He's a millionaire, and this is what interests him. It's going to be beneficial for everybody. Good for him. You know, I'm behind him. I really like him.
Yeah, me too. He's a good guy.
Anyway. But Rocket Man did have a question for you.
Okay.
Why can't we look at the entire transcripts for different missions? They're funded by tax dollars, which are from the people, so why don't we have websites full of data from missions? Excellent question.
It is an excellent question. I do know that there's, and I actually found this myself the other day, actually, when I was looking. I found the chronologies online of the entire missions from liftoff to splashdown, and they were extremely detailed, and you saw exact times when certain things were done and said. Now that wasn't the transcript, and I'm wondering, I don't know actually what the status of those is. Now there's going to be somebody on P&K who's going to be able to answer this, because she's a Apollo specialist. She knows all there is to know about the Apollo missions, and when Keith decides to bring her on, that'll be one that's a question for her, because I don't know the answer. I don't know. I try to stay away from the politics and super top secret type stuff that might be involved, because it's not going to get us anywhere. It's just going to make us frustrated that we don't have access to certain information. Hang on, I'm just putting on the dew cap here.
I thought you were going to say you're going to put on an extra sweater.
No.
It is getting chilly where Mark is, so
yes, it is.
Hit that thumbs up, please. Share the links. Tell a friend.
Yeah, thanks, guys. All right, let me just get this up here. All right, I'll put that there. Okay, good.
Well, the frustration about not knowing why we can't get certain information and
Yeah, I'm with
all
you on
that great stuff.
Yeah, I'm with you.
I figured segue into a question I had for you.
Okay.
Because you've worked with the Navy and have military clearance and whatnot, and actually October the 4th up here in Nova Scotia, actually in the province I'm in Nova Scotia, it will be the 50-year anniversary of the largest UFO sighting in Canadian history up at Shag Harbor. Yes, and apparently people saw something hovering for about 2 days. It had 5 lights that went like 1, 2, 3, 4, 5 in sequence, and then all 5 together, and it crashed into the water. And the fishermen and the RCMP and later the Navy and the Coast Guard, they all went in, couldn't find anything, but then there was some place, Sherburne, was it? Like a top secret military base, and apparently they may have found a few pieces. So while everyone was looking at Shag Harbor, other stuff were going on just about 40 minutes from. And yeah, and I heard all about this just in the last few days. So details and more stuff is coming out. Apparently, we're getting more and more tidbits, but yet it's been I don't want to say covered up. The Halifax Herald covered it strong for about a week.
Wow.
And then they just kind of dismissed it as nothing to see here, folks. So please, you're the expert in this kind of thing.
Well,
What's the rest of the story?
All of us are experts with only with the knowledge we get, you know. And if we don't have any, if we don't end up with the full story or the full information, then none of us are experts at much of anything, are we? You know. But I can say that I do believe that what happened was that there was an object. It was seen by many people, and as you said, the RCMP, which is Royal Canadian Mounted Police, they were there, and there were like 10 of them that were dispatched because they thought that an aircraft had gone down, and they were there to immediately start a rescue operation. But people
and they ruled out there were no planes missing, no planes flying in the area. They ruled that out.
Well, they ruled it out only after.
Just so you know.
Yeah, they ruled it out only after.
Yeah, after the fact. Yeah.
Right, and that's fine.
But they did look into it. Just point that out. Yeah.
Yeah. Yeah. No, but the fact was, you know, the jury's out for me. I don't know what it was. It could have been something really impressively spacecrafty, but you know, I'd like it to be. But there's no one's giving any answers, unfortunately. Now, but a number of people saw this thing. Now they said it was trailing lights. It had lights on it, and I saw other accounts saying that it had flames coming off of it. And whenever I hear flames, I have to, you know, raise the cautionary flag that, okay, we got to be careful now, because what if this was just one of those large meteors? I saw exactly as described, the thing that they say they saw at Shag Harbor. I saw in Hartford, Connecticut, when I came out of graduate school. I'm not saying it was a meteor. Don't get me wrong. But when I stepped outside, it was pouring rain, and I was like, "Oh man, I got to run to my car in the rain." All of a sudden, I saw this strange shadow of a street lamp that was standing up in the middle of the parking lot. And it was extremely bright, and it was passing. It was moving. The shadow was moving. That is to say, the light source was moving that was causing that shadow. And I looked up, and through the rain clouds, I saw this bright green meteor flaming behind it. You know, and it was just bright and green. It went from, you know, the far left horizon to the far right horizon, and kept right on going. It was basically what's called an Earth grazer. It's a meteor that basically missed the Earth. You know, it didn't have an angle enough to, you know, penetrate enough. So it ablated enough off, it burned off enough of itself, and then it just skipped off and kept going. So that so I have to say, well, if people saw flames, then we have to expect that could be the case. Another case that says that we have to be cautious about this is, I was here, it was 2 in the morning, and I got a phone call from the state police, all right, saying, we have a report of an unidentified flying object that crashed into Bantam Lake, which is a lake up here in Bantam, Connecticut. And I said, well, we can test right away whether it hit the lake. You have anyone on site? And they said, yeah, we got someone on their way there now. I said, okay, go to the boat landing and see if there's any debris washed up higher than the level of the lake, and see if it's still wet. All right? That'll indicate
What?
a very
Say
large,
that again?
well, if on the boat launch, there's a ramp that gradually goes down into the water, right?
Okay.
If you look at that boat ramp, see if there's any indication that the water was pressed further up the boat ramp by something,
Okay.
like a big splash. Okay?
Yeah, okay.
Yeah. And so they had that, and then I said, okay, the next thing you do in the morning is go look at the lake from the highest point you can get to, maybe the top of the clubhouse for the golf club that's right nearby or whatever, and look down on the top of the lake. Look down on the lake as best you can, and see if the color is the same, or if the lake looks particularly muddy in any particular location. All right. Then, if you see water that's washed up and you see that the lake is muddy, that's a good indication that something hit the water. Okay? Well, none of those things were seen. Yet, I had a state trooper himself say that it went into the lake, because he saw it, quote unquote, with his own eyes. And then neighbors saying that it went into the lake. What they saw, though, was a meteor that was heading, parallel. It was parallel to the ground, heading across the atmosphere, and then it skipped off into space. But why did it look like it was hitting the lake? Well, we live on a sphere, and a meteor at 80 or 90 miles up, or 120 miles up even, is going to look like it's going down as it passes over your head from behind you. It's going to look like it's going down, and then as it does that, it's going to have a bright reflection in the lake. And where that reflection in the lake meets the meteor, or if it doesn't, if it's not a big lake, if the meteor just flames out or goes away, and disappears, then you could easily mistake that for going in the water. And that's what happens, a lot of the time. I was talking to someone today. I'm going to be on, just so you know, guys, on Friday from 8 to 10, I'm going to be on KGRA on Don Ecker's show. Don Ecker's a very highly acclaimed specialist in ufology. He's also highly acclaimed in the private investigation field. Okay, the man has worked with all kinds of people at all kinds of levels, and especially in military. And Don wants to have me on. We're going to have a talk, and we're going to talk about some really cool things. But that said, if you're going to be around Friday from 8 to 10, I won't be able to stream because I'm going to be on Don's show. And then Thursday through Sunday, I won't be around because there won't be any SkyTour live streams unless I'm streaming my talk at the conference that I'm going to do. So I may do that. I streamed the one at Devil's Tower, so I might stream the one that I do at this other New England UFO conference. So that'll be pretty cool if I can do that. So I'll let you know on that. That was
Okay.
an aside.
Wait, I just got Don's link in. Where can I find the link to this conference in New England? Is there a link I can get?
I think it's the New England
chat?
UFO. It's the New England UFO conference, and they're just look it up and see if you can find the link, because I don't know exactly where it is.
Friday, October 6th.
And the
And
7th.
the 7th. I am assuming it's this one. 2-day event. Oh, Nick Redfern's going to be there.
Yeah. They could be there. Is it
Men and
Leominster?
Women in Black, Cryptozoology.
Yeah.
Okay. Sasquatchettes.
Yeah.
Oh my god.
No comment.
Paul Eno, Mark D'Antonio,
Yeah,
MC Peter Robbins, Travis Walton. Very nice. Okay, this is the one. This is the New England UFO Conference.
Yep. Yep. And the New England UFO Conference, I've been doing it every year since it started. And I was doing it just because I wanted to see it take off as a nice little conference. And it's been growing every single year. You know, it's really cool. And by the way, folks, the crater you see at the center there, that's Tycho with the extensive rays. That's 85 kilometers across, okay? And when the impactor hit to create Tycho, in the 1/6 gravity of the moon, that ejecta flew up and just went very, very high into the lunar environment. We actually call that when you can't say atmosphere or into the air, okay? It's actually got a special name. Here we have an atmosphere. There we have an exosphere. So the lunar exosphere is the area around the moon, okay? So just so you know, that's a little terminology for you. So the ejecta from the Tycho impact really shot up high in the exosphere of the moon, and then just began to fall down. And you can see how there's certain streams of ejecta that are denser than others. Now, ideally, the blanket of ejecta is going to be just a round fan, like just a fully completed, circular 360-degree, evenly distributed fan. That's what you would expect. But how come on the moon we have these rays, like this? Well, rays are the result of the terrain, the topography. They're the result of the impact speed, the angle of impact. Okay, if you look at the crater Messier on the moon, which is a little bit too small to see here, actually, it's not in the view. That ray structure is starkly, it goes. You see the crater, and it goes starkly to the left, or the right, depending if your image is reversed. And when it goes to the left, you actually see, these bright rays going out from there. It's really, again, because of the angle of impact. And then there's another lunar crater where it would have been a completely round, homogeneous impact blanket, ejecta blanket. But the fact was, when it actually struck, the crater that it made was right at the base of a cliff. All right, and so you only had ejecta and rays that were off to the sides of the crater, and it made it look really odd. Only to one side and the other. So the left and right had a wonderful little ejecta blanket, and then above it there was none. So you said, wait a minute, that's a weird looking crater. What the heck's going on there? Well, then when you actually go into the Lunar Reconnaissance Orbiter quick map and you take out the tool to draw a line and get the topography shape, you see that there's a very high ridge just below that crater, and that when the impactor struck and made that crater, the debris hit the face of the cliff and then bounced off, and that's why it looked the way it did. So there's always a good reason for things if you look. So I was impressed with that. I just want to let you know, because I think that's pretty cool.
That is very cool.
Yeah.
I know. Well, I was gonna say Jude dropped by a little while ago, and she was glad that you mentioned the craters. So yeah, guys, do let us know. Would that be something you would be interested in getting your own little piece of the moon or Mars, or
well, yeah, it's a 3D
anywhere
print.
you can get the measurements, the blueprints, so to speak, whatever.
Yeah, I mean,
you could do it, right?
Yeah, see, we got we're making these. They're about 4 1/4 inches square, and they'll be varying depths. Depends what we shoot, and actually make. But we're gonna do this, and I gotta, give a shout out to Jude, because she's actually doing a large amount of work here trying to get them ready. She's gonna have them up on the FX Models Planetary Replica page, which is our companion site to FX Models on Facebook, and she'll be able to have those images up there so you can see what they look like. I mean, these are just beautiful craters. I mean, they're just stunning, and not just because I'm making them. I wouldn't, well, I think you guys know me. I'm not going to make anything that's crappy. All right, I'm not going to do a lousy job. Now,
Well, this is what he does for a living. He's a professional. You know, it's not just a hobby. It's not just, you know.
you're right. It's not just a hobby. It's not just a job. It's an obsession.
Yeah.
Yeah, it is an obsession.
Well, no, I mean, yeah, this is your life.
It's an
I mean,
obsession.
if I don't know, if I was gonna go to anyone, and again, yes, maybe I'm a little biased, but really, I
Oh,
mean,
thanks.
you know your stuff. You're only going to sell things that you think are quality. You know, like
Yeah.
I don't know.
And I only do it
Whatever.
if I think, you know what?
Anyway, but that
I only do it if it's something I would like to have for myself as well. You know? Yeah, I'll do all the work to make them, but then I'll have some for myself, and then I'll say, wait, I'll bet you other people would like these too. You know, that's kind of how I've been running my business, which is interesting. It's actually kind of worked out, which is lucky, because you know, it didn't have to be that way. You know. But I'll tell you this though.
actually, yeah.
Go ahead.
I was gonna say I'll throw the link in for our friend Bill, Bill NY Skywatcher.
Mm-hmm.
He actually has the video. It's back in May. You'll have to go through his playlist. When he actually dropped by, him and a few others like Paul and Keith, the P&K Space Imaging, and Heidi, our good friend Heidi. Wish her well tomorrow. People dropped by, and he actually gave them their own little crater, their own little. Well, what was Heidi's was the Rosetta Stone, I believe, and a few different craters from Mars and the Moon.
No, actually.
So you can actually check these things out. Check that video out and look.
Heidi's.
No?
Heidi's. You know, it wasn't Rosetta Stone, but it's easy to make that mistake. The thing that Heidi got was actually the Churyumov-Gerasimenko comet, which is the target for the Rosetta mission.
It's a mistake to make.
Huh? What?
Mm.
What did you say?
I said, oh, that was an easy mistake to make.
Yeah, that's what I'm saying.
Rosetta Stone sounded nothing like what you just said.
Oh no! But Rosetta was the name of the mission. Rosetta was the name of the mission to land on the comet. You can call it, you know, CG, you know, or 67P, whatever you want to call it. Okay, but the fact is, that cometary mission, the comet was well studied, and there's actually a digital model of that comet available. So I printed it. I said, why not? So I printed it. It was the first thing I printed on that printer. And I got this beautiful comet, and man, it's the ugliest looking, stupidest looking thing you ever saw in your life. But, you know, it's a comet. And now you say, well, wait, what are comets made of if they can look like this? Well, comets are typically made of volatile materials. That is, materials that in the heat of the sun or the radiation of the sun, they will evaporate. Okay, they will boil off. They will change their chemical composition. So comets are generally very, very old. And those that are out in our solar system that, you know, are thought to have come from the Oort cloud. That's O-O-R-T, Oort cloud, which is beyond the Kuiper belt, all right, which is beyond Neptune, from 30 to 50 astronomical units past Neptune. And the Oort cloud is this big spherical collection of cometary debris that's outside our solar system. And once in a while, a passing star will perturb or disturb a little comet, and they will make its long journey into the solar system, where it could hit Jupiter like Shoemaker-Levy did. It could just circle around the sun, as most do, and then go back out, never to come back again, or perhaps get trapped in an orbit that brings it back periodically, like Halley's Comet. You know, so that said, we have a whole bunch of comets in that outer part of our solar system, and they are composed of there's ices, of course, there's water ices, but there's also other compounds on them, organic compounds as well. And when you get near the sun, the comet heats up and it starts gassing out these things. It starts shooting out stuff, and that can sometimes change the way the comet's rotating and moving. And so the CG 67P, the comet that we landed on with Philae, the lander, which kind of got stuck in a crevice, unfortunately. That particular comet, as it passed the sun, it evaporated a little bit. A bit of it got fried, that is to say, it evaporated, and the comet became just a little bit smaller. because it left behind a lot of dust. It left behind stuff. So as it's traveling through space, it's accumulating dust that's out in space. So that's why comets, have this this look. They're almost black, actually, and they will accumulate this junk on them, and so they might that'll hide the actual structure of the comet. And what many people think is that comets, like when you look at CG that Rosetta landed on, when you look at that, it's like got two lobes on it. It looks like it's two balls kind of like stuck together in the middle with a very narrow waist, kind of like a dumbbell, but not really. It's a kind of an oblong, deformed dumbbell. Well, how could that be? What is that actually made of? Well, what it could be is that it was actually two separate icy conglomerations that sort of kind of came together through mutual gravitational attraction. And because there's no big force on them pushing them around, maybe they're just loosely held together. There's some asteroids, in fact, that are just rubble piles of material that's just sort of held together very loosely by their own gravity. And then the dust and stuff settles on them to make the appearance that it has a surface. But the fact is, it might just be a loose rubble pile. And if you were to bring any type of large craft and swat it, it might just disintegrate into millions of pieces. Of course, it would have to be a very large craft. But anyway, so that's how in the cometary world, that's what comets do, and then comets are very, very interesting indeed. We've been hit by comets. The Tunguska event may very well have been a comet. Some people say, well, it might have been a spacecraft crashing. Well, yeah, but like Shag Harbor, okay, it stands to reason that it could be something else too, and we can't ignore that just because we want it to be something different. So that's all. I just thought I'd mention that.
Yeah, it's I don't know. I like that Philae thing. I thought it was so cool. I was devastated when it fell in the crater.
So was I. I was just like, oh, no way. But see,
well, your friends worked on that. Didn't you have a hand in that in a roundabout way?
I didn't have a hand in it, no, but I knew people that worked in the project, and one of the problems was they designed this grapple so that when Philae the lander landed on the comet, the instant it registered touchdown, it would swing out its arms, and these arms had spikes at the end, and they were supposed to penetrate the comet and hold it in place and anchor it, because the comet had low gravity. It didn't have a whole lot of gravity, but it had gravity, but not enough to allow a soft landing that would not cause bouncing and then skipping across the surface endlessly. So when those grapples were deployed, they either deployed them a little too soon or a little too late. And what that did was, it in fact was like bending your knees and jumping. It ended up jumping back off the comet. It went several kilometers back up in the air, then came lazily down again. Okay, where now, it was just floating aimlessly as it did that. And then it finally ended up lodging in a crevasse. And I actually saw the image of it in the crevasse. I saw the discovery image. I found Philae. I wasn't the one to find it, but I found Philae after looking at the discovery image of where they said Philae is in that image somewhere. And it was definitely wedged in a crevice, and it was like, oh man, talk about never having a chance,
But I mean, to say they deployed the little grappling hooks a little too early or a little too late, I mean, they launched that thing at least 10 years before it hit the comet, and they figured out the trajectory, and if we launch it here, it'll link up here in 10 years. I mean, that is crazy math, and I mean, it just seems so unbelievable for it to even connect in the first place. But then to go down like that, I mean, to me, it seems like a miracle shot. But I mean, obviously, they have the math that this is going to probably be a pretty definite thing as far as they're concerned. But
well, they thought it was a long shot too, but they were hoping, and it didn't work this time. But usually they do. Usually they do very well.
That's still That's an astonishing feat.
Yeah. By the way,
I
I'm
mean,
gonna take us to another object right now.
we
So,
do actually have requests coming in for objects too. I don't
awesome.
know where they are in the sky, but
Let's
actually,
see.
I was talking to Tana the other day. I guess that's maybe why she thought of the question.
Okay.
And we were talking about things. I hope this is the right one, because we were talking about like the sparkly ones, and I was talking about the blue diamond.
Yeah.
And she said, "Oh, I think that's the one that I really like." And I said, "Well, if it's the one I'm thinking, it's Vega, and we go there quite often. Is that up and around? Can we see that tonight?"
What, the Star Vega?
Yeah.
Yeah.
It doesn't have to be now, but I mean at some point
Yeah.
tonight, maybe.
Yeah. Well, we'll have to. We'll definitely have to see it soon because it's going to be setting.
Okay. And Maureen, I don't know if she's a newcomer. I'm not quite familiar with her name, but she enjoys the Galaxy nurseries. She thinks they're truly awe-inspiring. And I said, I'm not sure if we can see them, but I would ask.
Okay.
Are there any potential we could see tonight?
Well, when you say Galaxy nurseries, do you mean the?
I guess where stars are born is what I'm thinking.
Stellar nurseries?
I don't know. We'll see.
Because if you're asking about stellar nurseries, then I believe we'll be able to. I think we'll be able to do that. But
what else is there? What else could she mean?
Well, okay. Well, there are stellar nurseries in galaxies that we see. Okay, and that's something we could be looking at or looking for, but we don't actually. We don't actually have a good night for that, based on the fact that we have an unfortunate issue with the moon, you know. So we don't really have a good sky for looking at deep sky objects like that, which is kind of sad, but you know. Let me just zoom in on this guy right here. Yeah. There we go. Okay, see that little pale blue dot?
I do.
Okay, that pale blue dot is not the Earth. Carl Sagan would say so. That pale blue dot is Neptune. So let me.
Oh, I was gonna say.
Back out. See, this is it. It's sitting all alone. And let me just gonna reduce the setting here. I'm gonna go to 12,800 for just 1.3 seconds, just to get a photo. Okay, so there. This puts it in perspective, so you can see where it is. Okay, so there's Neptune. Okay.
For Sailor Moon fans, that is the same color as Sailor Neptune's hair. It's such a gorgeous color. I love it.
That's right. You are that fan.
There are a lot of us.
Yeah, I know there are. Yep. Now you can see in this image just above Neptune. You can see its moon Nereid. Okay.
Nereid?
I think that's Nereid. Wait a minute. Let me just check. No, that's Triton. Sorry. That's actually Triton. Okay, just above Neptune in the center there, not the whiter dot that's down to the lower left of Neptune, but just above Neptune, about the width of Neptune itself. You can see Triton just above it. Can you see that?
I do. What's the little one to the left of it? Is that... What was the other one called? Nibit?
Nereid.
Nereid?
Nereid, yeah. And Nereid should be just to the left, but I don't...
I mean, that's crazy. I mean, not only are we seeing Neptune, but we're seeing some of its moons.
That's correct.
That is so crazy. Like,
it is, you know. And then Nereid is actually fairly far away, but it might be in the same view. Let me just go see if I can find it. So there's Triton, and Nereid's also up top here, if we can get there. That's not... Wait, let me see it. Hold on. Just a second. I'll tell you in a minute. To the right and to the left. Okay, so... now it's to the left. So, to the left of that, we should be seeing Nereid. And That's too far. Yeah, okay. I don't see near it in the shot. Sorry. But there it is. I mean, there's Neptune for you with its moon Triton.
What's that big white? I want to say star, but who knows? I mean,
No, good call. That's actually
kind of like, I don't know, what, like 7 o'clock?
Yeah, that is a star. That's actually the actual designation of that star is it's actually got a name. It's called HD 216662. I know, 666. Woo! Yeah, but that's Neptune, man. I think Neptune's beautiful, you know.
Okay, so now, obvious question.
Yep.
Why does 666 there look so much bigger and brighter than a moon? Like, even, is Triton the biggest moon of Neptune?
It's fairly big.
Largest?
Yeah, I think it is. But it's also, you know, brighter than, or as bright as Neptune, you know, but you can see in this shot here, this is a live shot now. Okay, see it's live because I'm jiggling around. Okay, you can see that Neptune is clearly the brightest thing in the sky other than that star in the upper left. Now, Neptune is far away. You know, Neptune is 30 astronomical units away. And you're actually looking at the farthest planet in our solar system as defined by planets.
That hurts. Don't. Well, I was going to ask you a question about that when you were talking about the Oort cloud and the Kuiper belt and blah blah blah.
Sure, go ahead.
And then you said, and then that goes out to the end of our solar system at Neptune.
Yeah, because Pluto is not included.
Pluto in the Kuiper belt?
Well, Pluto is what's called
technically.
Pluto's called a trans-Neptunian object now, and it's actually a dwarf planet. That's what it's. Unfortunately, the end of our solar system here is right here. We're looking at it. This is Neptune. This is where our solar system ends now. Unfortunately.
Okay, well, what other objects besides Pluto are trans-Neptunian objects? All of Pluto's moons as well?
No, it has 5 moons.
What are they now?
They're the dwarf. They're the moons of the dwarf planet Pluto. Here's another shot of Neptune here.
Okay, but where technically is Pluto then? Because since it got demoted, if Neptune is now technically the end of our solar system, then by definition, the next thing past our solar system is what? The Kuiper belt? Or Kuiper?
Well, yeah, but then again, okay, Pluto is still out there. It's just a dwarf planet that is the next object of merit out from Neptune. They're not allowing it to be called a planet anymore. However, after seeing it and looking at what's happening on the surface of Pluto, there's a number of scientists actually that are kind of saying, I'm not so sure this was a good idea to demote it because it's showing some very complex processes on its surface. You know, it's really, really got some heavy-duty stuff going on. So it's pretty neat to think about this. Now the thing is, when I'm looking up in the sky here and looking at Neptune in a telescope, I mean, all I see in the sky is just blue from the moon. And of course, it's the same blue color that we see during the day because it's the same scattering of sunlight that's happening. I'm sliding my footstool over so I can just rest my foot on it, so I can curl my toes and warm up 1 foot at a time.
I told you, bring extra everything. That included socks.
Me. Yeah, I know. So let me see now. Now we looked at that, and we're looking at Neptune. So let's go take a look now at something else.
Oh, by the way, Maureen said the nursery she was talking about were the galaxies that Hubble captured.
Oh, okay. So, all right. So she's talking about galaxies then.
Yes.
There's galaxy clusters out there. Yes, there are. Now we can't see galaxy clusters on a night like tonight, and of course
because of the moon.
Yeah, the moon really just hides them really well. The light is so faint from those things that the slightest light causes a problem. But don't worry. When the time is right, we'll see them.
So when should we try again? About 2.5 weeks?
I have to look and see if there's any clusters. Like, I know that we lost the option to look at Markarian's chain, which is a bunch of galaxy cluster. That's a galaxy cluster that's out in the Virgo area, or Leo, and we can't see Stephen's quintet, which is another interesting collection of galaxies.
Who's
Yeah.
Steven?
Oh, he was the guy that found this cluster out there. This cluster of 4 galaxies that are all huddled together. Stephen's quintet, it's called. Stephenes. Let's see here now. All right, I'm looking now at. Oh, you know what I'm gonna show you. Every now and then I like to. Let me see if I can do this. Make sure this is actually available. Oh, I think it is. Okay. We're gonna go look now. We're just gonna go look at a star right now. But I'm showing it to you for a reason. So here we go.
Like more of a low grind from that telescope than the.
Well, you heard me. Yeah, it was me doing that. I was trying to do something here.
Oh, I saw a red flash on the screen.
Yeah. Okay, this star right down here. Okay.
Mm-hmm.
This star is the brightest star in the constellation Pisces Austrinus. Okay. It's called Fomalhaut. Okay, Fomalhaut. Okay, and Fomalhaut is actually an amazing star.
Ooh.
Because we discovered on Fomalhaut, we discovered that there is a debris disk. In fact, 2 of them circling Fomalhaut, and Fomalhaut actually has one planet that's in formation that we could see. And it's really an interesting star. And it's actually, in 2008, okay, that particular planet was actually imaged with regular visible light, like you see with your eyes, okay? And that's a fascinating thing, because most of the planets have to be seen in a different way. They have to be inferred from the data. This is the first time that we actually saw the actual planet itself in its own light. We don't get to do that much, because the planets are very, very hard to see because they're so small. But we actually imaged this large planet circling far away from Fomalhaut. So that was really cool, and now they have actually named it. The planet that's circling Fomalhaut is called Dagon. Dagon. Okay?
Oh yeah, you'll spell that for us.
I did.
What about the other one?
What? Oh,
The
Fomalhaut?
German one. Yeah.
Oh, okay. Fomalhaut.
I missed it all.
Yeah, I bet you did.
F-O-M-A.
Yeah, Fomal, Fomal, and then Haut, H-A-U-T, Fomalhaut.
I would have got the H-A-U-T, actually.
Yeah, because I said Haupt. She probably would have got that. Fomalhaut. And many people spell it, F-O-M-A-H-A-L-T, so you think it's Fomalhaut, but it's actually Fomalhaut.
Mm-hmm.
So, and I think that's pretty neat. Now, so this star actually has a planetary system that's in formation. It's pretty cool because the star is actually a very interesting star. It's 25 light years away, so it's not that far, relatively speaking. And it gives us the chance to actually see the planets. Now, the James Webb Telescope is going to probably look at this, find it again, and see if it can see anything else. Now, the thing that's interesting is that this planet that was seen here doesn't transit in front of the star. The disk, okay, that we're looking at, if you look at the screen here, let me just bring this down because I let it go up. All right, if you look at the screen here, okay, imagine the disk being like, you hold your hand out with your palm and your fingers outstretched, okay? If you press it up against the screen, that's about the size of the disk, the debris disk that was seen. It's actually hundreds of orders of magnitude smaller than that. But what I'm getting at is the actual disk is actually flat to us. So we don't see a star, we don't see a planet that's actually crossing in front of its star, dimming the star's light like we do with the Kepler. This was seen differently, all right? And so when this was spotted in this survey, they were looking at the debris disk, the dust disk around Fomalhaut, and saw that it was a circular dust disk around it. And then they saw this area in 2008, and then 2012 they looked at it again, and they saw that this dusty, knotty collection that looked like it might have been a planet had moved at a rate consistent with something that might have been a planet orbiting the star at that distance. So that's what turned them on to the fact that, wow, we actually caught a planet. Very, very cool. So I don't want to dwell on Fomalhaut for long. I just thought that since it's in the area, we would check it out. You know?
Well, Maureen just said it means the mouth of the fish. And
Yeah.
you said it was the brightest star in Pisces. That's really cool.
No, Pisces Austrinus.
What's the difference?
Pisces is Pisces. Pisces Austrinus is Pisces Austrinus.
Okay, Pisces is a constellation. Pisces Austrinus is what? An asterism?
No, it's a constellation also, but it's a typically it's a kind of a southern constellation, and we're seeing it here because this is some of it that sticks up above the horizon. We see Pisces Austrinus here, so we see an element of it.
But
I mean, this is
but I mean, I don't know. Is it a totally separate constellation
Yes.
than Pisces? Okay.
Yeah.
Okay, so it's not in the
It's not in the zodiac.
zodiacal orbit or
Yeah.
zodiacal orbit?
It's not a zodiacal constellation, correct? But it's very close.
No, I knew it wasn't a constellation like one of the 12, but I mean it's not.
Yep.
It's not in that orbit. It's not in that.
No, that's right.
I'm trying.
No, that's good. That's fair. That's fair.
Well, Daryl was saying he always thinks of it as the lonely in the south because I guess of what you were saying being in the southern.
All right, now we're going to go to something else. Let's see if we can see it.
George Harrison was a Pisces.
Oh, I wouldn't know. But you would.
My dad's a Pisces. Him and my cousin are born on the same day,
Wow.
and I believe it's the same as your son's. Possibly Hunter's
February.
in
19th.
February. Yeah.
Wow. February 19th, yep.
I wasn't gonna divulge that information, but
Hardly an issue. All right, now, let's look here. Let me look at a couple of things here. I'm just trying to figure out where we are. I got that star. I know that's where we are. And that would put that. I'm not telling you what we're looking at yet because I'm trying to make sure that we're golden. That star we're looking at, actually, that star you see in the middle, that star is called Albalda. Okay. Albalda.
okay, but you're telling me, so
Well, that's
I assume that's not necessarily what we're gonna zoom in on.
That's correct. We're not, but there it is. Okay. That's the star. It's
That
actually
looks kind of pinky.
well, that's kind of because it's near the top there. Okay. It's also a star that I'm looking at a hot spot on the left side of my screen there. I'm not sure what I'm looking at there. I shouldn't see that there. That shouldn't be there. Yeah, that's okay. All right. Now what I'm going to do is I'm going to move a little bit to this side and then head a little bit down. Okay. There we go. Now let's get this in here.
See, some of the odd names, that's why I always want to know. the
Yeah,
stories
no,
behind the names, because
fair
I
enough.
mean, unless they're naming it after themselves, the
Yep,
discoverer, or where it is in the sky.
yep.
I mean, how can we go from? Oh, I forget. I can't even remember the name of the last one.
Albalda.
Fomalhaut.
Oh, Fomalhaut.
Halt.
Fomalhaut and Albalda. Well,
Yeah, and then you
remember that
have
these names come from the
Stevens.
Arabic. You know, Stephen's quintet is, yeah. Well, don't
Yeah, and
forget,
then Stephen and what, the Bruce, was that the creator's name?
there was a creator named Bruce.
I mean,
There once was a
see,
creator whose
like,
name was Bruce. He
I
told the
mean, it's
tale 'cause he
crazy,
had a
like,
truce. All right, let's go in here and let's just take a look at something. Now, let's zoom in. Now, you may think we're looking at a double star.
but you'd be wrong.
You would be wrong, because that object that's very round in the center, right there, moving, see it's right there in this, basically in the center right there.
Hmm?
That's Pluto. That's the dwarf planet,
Wow.
Pluto. Solar system tour galore. Yep. That is our infamous little Plutonian satellite, Pluto.
What's the
The
bluey
that's
kind
a
of star?
That's a star next to it.
Does it have a name? Do you know its name?
No, I don't. It's a field star. You know, it's just a star that happens to be in the field.
Okay.
Yeah, but there's Pluto. So see now, if we were to just increase the exposure to say 8 seconds, and this is at 3200 ASA or ISO, 3200 sensitivity for 8 seconds. Now you'll see what that gets us.
See, now I know New Horizon took pictures of it when it was going by, but like, when did they first catch like Pluto's heart?
Oh,
When
that
did we
was
first see those pictures?
those came in with that when Pluto was actually imaged for the first time by New Horizons. They saw that weird shape, and they didn't flesh it out. They couldn't flesh it out until they actually got closer. And when they did, they saw that, and it was like, wow, that's just so cool. Just so cool.
But didn't see? Again, it's something I think I read, and I could be remembering it wrong. But didn't they say that they thought something had hit it? Like, I don't know if it was a meteor or asteroid or whatever, but something hit it, and I guess water came from the bottom of the impact.
You're actually,
and that's what filled it in, and that's what kind of makes it lopsided. It's a little bit lopsided.
yeah, no, actually,
I could be going wrong on that part.
no,
but
actually, you're actually very good. It's actually what happened was, see, most of the bodies in our solar system have all these craters. When they don't have craters, we have to say why. We ask why. And the reason that this particular one doesn't have craters in that area is because that area was resurfaced. Well, resurfaced by what? Resurfaced by some process. Well, what does that mean? Well, it means that some process that Pluto undertook after it was hit with something resurfaced it. Well, okay, the melting of the ices may have actually caused this amazing thing to happen. You know, it may have caused this resurfacing process to occur. So that's something that could have happened, and it's something that probably did happen. We know that this happens fairly often because we can see and detect that there are places that have been resurfaced. I mean, just look at the moon. Those parts of the moon that are dark gray, the Maria, those are resurfaced areas of our moon. Okay? Now, they happened billions of years ago, but still, they're resurfaced. Truly. So, I think that's fairly interesting, you know, to me anyway. So, and the same thing happens on Pluto. Same thing happens on other, there's some other moons that do that. Enceladus, Europa. All right? Europa is fairly dynamic. It's got a lot of cracks, okay, that are caused by tidal forces. And that's something that's really hard to quantify. We look at the forces, but we don't really know what's going on inside Europa. We don't know how warm those stresses are making the interior. We know that it's making them warmer, and we can say that with fair amount of certainty, but we don't know by how much. We don't know exactly what it's doing. But I'm going to go to your selected target, by the way, that you asked for.
Well, I'm just wondering if that's what tilted it, maybe tilted it off course, and that's why it doesn't orbit like the rest of the planets. Could they take that into account when they're trying to reinstate it?
That would be great. That would be wonderful. But I don't know that they will.
Well, I don't know. It doesn't have to be part of our solar system, but I think it's still... I don't know. It might even be more interesting to study than some of the other planets, in my opinion. And
it is, actually. And that's why some of the scientists are kind of saying, oh, man, foul, what are you guys doing, you know? Now, this
yeah, but I mean, we follow other things that aren't part of our solar system.
Of course we do.
So, yeah.
We do. There's no doubt. Okay, let's see here. Let's go to 10,000, and we'll do this for 8 seconds, see what we get. We're going to get a fairly blue image because we have the moonlight, but we also, this that we're looking at here is requested target number 1 for the evening, which I believe was Vega.
It was.
Look at
Ooh.
that. Is that not
Tana,
beautiful?
I hope you're still here.
Yeah, there's Vega. Really pretty. And that's that's an actual that's a very, very beautiful star.
It's gorgeous.
Yeah.
I don't even recall seeing it like this. Like it looks like dark gray in the middle, and then yellow, and then like almost like a green, and then just blue from everywhere.
Yeah, it's a beautiful blue, no doubt.
But it's almost hard on the eyes, really.
Yeah, well,
it's so bright.
It's pretty cool.
But and what's the closest thing to this that we can see just with our eyes, without, like, if we're out of the city, no light pollution or anything?
What do you mean?
What's the closest thing, this, like, a bright blue object that just stands out? Nothing? We'd have to have
a mercury
binoculars
vapor
or telescope.
lamp.
Pardon?
A mercury vapor lamp, you know? Well, but, I mean, this, I gotta tell you, when I was in Wyoming last week and a half ago, when I looked up and saw Vega, I just was transfixed. I was staring at it and then looking at Lyra, the constellation it sits within. I looked at Cygnus the Swan. I could see every star in Cygnus the Swan. I could even see faint objects within Cygnus that are invisible here, but visible there easily. And I was just stunned. You know, my feet were freezing. It was cold. I was leaning back on the back of a cold car, and I was just staring. And there weren't any cars that came by at all, except for the friends of mine that actually followed me out 20 minutes later and pulled up in front of me, and stopped and got out, and I gave them an impromptu skywatch. It was just amazing, you know. And you look at a star like this and you think, wow, you know, what an incredible construction this star is. You know, an incredibly interesting natural object. Now, Vega's close by too, just like the other star, Fomalhaut. This one is 25 light years away, and it's an A-type star. Actually, Vega in the OBAF GKM spectral classification, Vega is an A0, and the A0 stars are actually what we would call a kind of a calibration star. When I take spectra of stars You'll see my battery nipper. It's going to die. I'll change it.
I was gonna say, yeah.
Yeah, and I caught it.
Andy called that. Sorry, Andy, I did not see it earlier.
Thank you,
But
Andy.
I do see it now.
The spectral classification of Vega shows it to be an A0 and then V, 5. Natural, normal, hydrogen fusing dwarf. Our sun's a dwarf too, and Vega, like the sun, is on the main sequence, that snaky line through the middle of the stellar diagram that we see, called the Hertzsprung-Russell diagram. And as a calibration star, Vega is the one that I go to when I first start taking spectra for the evening to make sure it's coming in right. I get on Vega and I take a spectrum of Vega. Now, as we move along here, I'm going to do some spectral nights too, where we're going to actually use the spectral instruments to capture the spectrum of the stars. And you'll see these just amazing panoply of colors that the stars are giving off. But all the stars have a spectrum. They're all showing us a spectrum. In spite of their different colors, they all have a spectrum, just varying degrees of color. And based on its predominant color, that's what we see with our eye. And Vega, as an A05, okay, is actually an A star, and remember, O stars are the bluest, B stars are lighter blue, and A stars are white. So Vega is sort of artificially blued here because of the filter that I have, that I'm using. I've got that special filter in here right now because that actually gives us some good views. It knocks out some of the moonlight. So it's a little bit more blue than it ought to be, okay? But it's beautiful nonetheless. Just beautiful. Now there's a rumor actually there might be a dusty disk around Vega too, like Fomalhaut. And if so, then that means that maybe Vega is creating a planetary system. Remember? So, I've talked about that before. I don't know if you remember that.
Sorry, I was distracted. Rocket is just about to take off, but he asked a question earlier, and I meant to get to it, and then I got distracted, and I'm sorry. So I just asked him to hold on 1 second so I could ask you this.
Yeah, go ahead.
And it's going to be disjointed from what we're talking about.
Sorry.
He wanted to know about... Oh, and I lost it.
Oh, no.
Okay. Can you ask Mark how much his USS Dolphin submarine costs? I know it has nothing to do, because we were talking about the modeling and about the crater images that you were gonna possibly start selling, and that's why I put in the link to FX Models, and I was gonna ask it and got distracted. Sorry.
Okay.
Thank you.
No,
go ahead.
Actually, thanks for asking that question. Of the submarine models we make different scales. Dolphin is to scale in 1/192nd scale, and we also have a 72nd scale dolphin that's like almost 2.5 feet long. But the smaller Dolphin, which is the one that a lot of the former crew members would buy, that's a little tiny, basically a 10-inch long model, and it sells for $350, all finished with all the intricate details on the Dolphin, and it has all laser engraved detail on it. We spent a long time building that up and getting that out the door, and it's so accurate, in fact, that Dolphin has been decommissioned, as some may know, just like the NR-1, which is Naval Reactors 1. It was the first submarine of its type and only of its type. Dolphin was a diesel sub, and it was the deepest diving diesel sub. And the history of the Dolphin is checkered with amazing accomplishments. Dolphin was used as a test bed for many different innovations that the Navy had. And so since NR-1 doesn't exist anymore, and since Dolphin doesn't exist anymore, the Navy asked us to actually build the most accurate, highly accurate models of those two boats. You don't call submarines ships, they're boats. And so I flew to San Diego, and I spent several days in the dry dock with the Dolphin just prior to it being decommissioned, and I photographed it inside and out from stem to stern. I did the same thing for the NR-1 up here in New London, Connecticut, at the sub base, and what we made was models so accurate of the NR-1 and of the Dolphin that they were and became the official model for the naval or for the National Archives, because they showed all the detail. Every single rivet was where it belongs. And the small dolphins, only 10 inches long, is taken from the same exact file that we use to make the larger dolphin. So it has all the same kind of intricate detail on it that the larger one has, just in a small form. And you look at it and you go, how could you even do this? You know, because we just made it smaller, you know. So it's very interesting, a very good, very fun model. So it's $350 for the model. So that's long-winded, but I thought you deserved an explanation of where it came from.
Yeah, no, well, I don't really know anything about submarines myself, so
Yeah,
it is
no big
it's
deal.
very interesting to know.
Yeah, well, don't
Well, no,
forget.
I mean, I wouldn't have known anything like that, and it's cool that you can, you know, you have so much knowledge, not just about space, but
Inner space.
with the Navy and with the...
Yeah, don't forget.
Well,
Outer
I hear a
space and
lot
inner
of
space,
connections between boats and ships and stuff, and, you know, space missions.
Yeah, well, boats and, you know, when you think about basically what is a submarine? You know, it's a craft. Effectively it's a spacecraft, but it's traveling through the underwater spaces, and you have to change the sign on the pressure equation to actually you know, go into space with something like that. But it's very cool, you know, and so when you consider that the study of inner space, that is the you know, the ocean floor, is the space program of the earlier century. Okay, we still don't know all the ocean. We still don't have all the answers. We've been to the Marianas Trench twice, 2 times in human history. Once in the Trieste, okay, with Auguste Piccard, all right, and Don Walsh, and then when Jim Cameron decided to go down for a photo op. Those are the 2 times we've been to the bottom of the Marianas Trench as human beings. 7 miles down, it's called the Challenger Deep. Those locations are more like outer space than they are Earth, because the slightest mistake, the slightest problem there will in fact result in your instant death, same as in space. You know, if something leaks at that depth, even if it's the tiniest leak possible, you know what that is? That's a water jet. It's a jet of water so powerful that it would slice through your body as if it wasn't even there. So, you know, and same with space. You know, if a window breaks in space, you're gonna go through that window like the Play-Doh Fun Factory. You know, you're gonna.
Great analogy.
Yeah, right. You know, the fun never stops at the fun factory. Ah!
Oh my god.
Yeah. Sorry, I know. But truly, you know, inner space and outer space were never really that different to me. So I was very attracted to inner space because I had access to inner space. All right, and of course, I decided to make my mission in life to study outer space. You know, and as far as walking on the surface of this thing we call a planet, well, that's just a bonus. I'm happy to do that too. But it's just, you know, it's really interesting to me that all the science that goes into play. I mean, I actually have plans to build a small remotely operated vehicle, an ROV, that will go to you know, full ocean depth. Now you think, well, wait a minute, the pressures are so immense. How can you send something down full ocean depth? Well, just like going to space, right? You have to send something up into space. You have to be able to endure very low temperatures and very, very low pressures, if any at all. Okay? When you go into space, you have to endure, go into the water deep down, you have to endure very high pressures. All right? And you have to endure very cold temperatures, once again. So, how do you do that and do it in a way that you can survive it? Well, if you send a robotic vehicle, it's a little easier. But how do you keep your robotic vehicle from being crushed? Well, here's a little tidbit of information that you may or may not know. If you could fill your lungs with a oxygen-saturated solution, and in other words, have no air spaces in your body, okay? Put some behind your eardrums to make that all even, okay? Fill your sinuses with it, and then make this liquid in your lungs be full of oxygen so that you could actually extract oxygen from this liquid and even put a pump in there to pump it through. You could just drop off the end of a ship and go right to the ocean floor, right to the bottom of the Challenger Deep, and you'd be just fine. You see, when you dive in the ocean or in the water, you feel the pressure, don't you? And as you dive deeper, you say, oh, that's too deep, and your nose hurts, your sinuses hurt, and you got to clear your sinuses by holding your nostrils closed and blowing hard, and popping your eardrums. Well, if you had all liquid in your sinuses and in your ears and in your lungs, then there's nothing to compress. There's no danger, and you'd be fine. So, literally, we're one evolutionary step or even technological leap away from being able to walk along the bottom of the deepest ocean with impunity. Now, this brings to light another issue. In the earlier years, the Navy experimented with this supersaturated oxygen solution. In the movie The Deep, you saw them drop a rat into the solution, and he was breathing this stuff, Okay, it actually happened. It was an actual real live demo of this glycol solution, and this thing breathed it because that's what the Navy SEALs did, and so they tested it and they found that it could work. The only problem was the issue they had was that getting it out of the lungs was a very, very long, drawn-out, dangerous process. And basically, you're giving a SEAL diver pneumonia. Fluid-filled lungs. And yes, it's oxygen solution, but when you go back to breathing air, and that oxygen solution is already desaturated of its oxygen, now it's just liquid in your lungs. So getting it out is a serious problem. So these guys basically had to fight for their life just because they want to try this way. So it's an evolutionary thing. We're going to have to evolve to be a sea people if we want to go back to the sea from whence we came. After all, that's why your skin is salty when you lick it, okay? Because you have the salinity similar to the ocean, because we came from there, and we depend on salt. And that's why you're salty, because you were once an ocean being. Just thought I'd throw that one in for fun. So that's...
Well, see, I thought... Again, things that I thought I read a long time ago,
yeah.
I might be confusing, because I can't... Because I was going to tell you something, and then I'm like, but I can't remember where they said they were aiming, but I thought I heard, and again, this was a long time ago, I thought I read something about they were going to send some kind of spacecraft with submarines. And I don't know, I mean, they couldn't, I mean, there is water on the moon, but I mean, they were planning on, like, dropping the submarine under the water.
You're right. You're right.
Somewhere on a planet or a moon.
It was a moon. And
that's crazy. Why isn't that top priority?
It was Europa, actually. They thought about dropping a small submarine, an ROV basically, under the ice mantle of Europa. And this would allow them to actually see what's down there with an actual submarine. We're going to have to do that at some point. I'm moving, by the way, to another object. I'm going to move to a star cluster that I like a lot. And we're going to see how it looks in this moonlit night.
But, okay, go on with Europa and submarines.
Yeah, so they were going to drop it into onto Europa and then drill a hole and get down into the ocean below Europa. So, I don't know how that's actually going to happen. And I see that I'm going to have to be taking the battery out here. You'll see it may not even survive this, but we'll try it. I'll get to this in a second. I'm just going to change my battery here.
Yeah, you always have extra batteries.
Of course I do. Mm-hmm. Can you imagine if I only had one battery? Oh, well, we're done.
Ooh, that's pretty.
Yeah, that was a starry scene.
Quite actually. Blue, but I mean...
Yes, the moonlight.
I like blue.
We're near the moon, that's why, unfortunately. Yeah, I like blue. Yeah, well, it's not supposed to be there. To an astronomer, it's the bane of their existence. But that's okay. Alright, let's put this in. I heard this make an extra maneuver that it shouldn't have made. So, as expected, it did not have the object in there that I was looking for. So I'm gonna go back to it. I'm wearing gloves, so I actually ended up hitting it with a gloved hand. There we go. Now we're moving over.
Yeah, and for those of you watching, you can see in the bottom left-hand corner, there's a little square, and you can kind of see a red glow. That's Mark inside the dome.
Yeah, here's the telescope.
Oh, he just turned the light on.
So now you can see.
So he's trying to change the battery in the dark and move the telescope and bring us these images. So, just so you know, this is why we appreciate your patience.
This is the telescope here. Yeah, I don't know if you can see that. This is the mount, and it goes up over my head here, and the computer is over there, and the camera's right there. Hi.
And I was gonna say wave at the people, but it looks like you have one of those lights on your head, and I think you just blind us all if you looked in the camera. Yeah.
I would. But
I saw your hand wave. Thank you.
Yeah, I did. Okay, I'm gonna do 4 seconds at 12,008. No, 12,800. Yes. You know, there it is. That's the wild duck cluster. One of my favorite clusters. I really love that thing. And it's just a beautiful cluster. And it's actually just a it's a cluster of stars. It's not it's not a globular cluster. It's just a stellar cluster, you know. And I like this because of the fact that it's a open cluster. It's an open cluster of stars, but it has its own beauty. Because of the nature of its sorry, I'm doing 5 things at once. It has its own beauty because of the nature of the stars and the way they're placed in the cluster. I'm going to go back down on this a little bit, drop down to 5,000 ASA, and just go for 8 seconds. Let's just grab an image of the cluster itself without so much blue.
And sorry, what cluster are we looking at now?
This is the wild duck cluster.
The wild duck cluster.
Yep.
Okay.
Yeah. Now this is a cluster of stars. It's 4,800 light years away. All right. And when we look at it, in fact, I'll move it over a little bit too. But when we look at it here, we go into this now. Let's just zoom in a little bit. All right. Now we look at the cluster. You can see, if you look just to the right of center, of course, you see a bright star just below center of the cluster, or just above center, depending on your perspective. And to the lower right, you see an orangey star, and then to the right of the bright star in the very center, you see another pair of orangey stars out there. The wild duck has this. It's an interesting cluster because of this. You know, this makeup of the stars. So I am always impressed by this cluster, and it never fails to bring me a great sense of wonder and awe, you know. It was first discovered by Gottfried Kirsch in 1681, believe it or not, and it was the first resolved into stars by William Durham in 1733. Charles Messier included it in his catalog up in 1764, so you see the chronology of when this happened. Now, the common name, the wild duck cluster, actually comes from Admiral Smith, who noted that his its fan-shaped appearance resembled the flight of wild ducks. Obviously, hunting was a big deal back then. So the cluster is 14 arc minutes that we talk about in diameter, and it's about a third the size of the full moon. All right, so it's actually a fairly big cluster. And it's like I said, it's actually I made a mistake before. It's actually 6,100 light years away, not 4,000 something. It was 6,100. My mistake. So as a cluster, okay, we get something called the overall magnitude, or the overall brightness. Now, the magnitude is an interesting thing. Magnitude is, unlike other things, the higher the number, the fainter the star. Usually the higher the number, the bigger something is, right? Well, it doesn't work that way in astronomy. Welcome to my science. We actually talk about magnitude as in brightness of the stars, and we say a 14th magnitude star is fainter than a 12th magnitude star. And a first magnitude star is extremely bright, and a 0 is even brighter, and a -1 is even brighter.
That is where it gets crazy.
Yeah.
That it stops making sense.
Mm-hmm. Yeah, well,
I mean, if
Vega's a magnitude
one
0. A 0 actually is like 0.05 or 0.1 something. So.
Okay, well then, what is the brightest thing in the universe? What number would that be?
Well, the sun
like
is
minus
bright.
100.
Well, yeah, kind of. The sun's minus 26, right? All right, and the moon is negative. I don't know the negative. I can't remember the actual magnitude brightness of the moon, but the sun's minus 26. All right, so that gives you an idea. Now it's something called a logarithmic scale. So
Can we look that up? Is there like a website for that, and you can just type in things?
Sure. All you have to do, go into Google and look up stellar magnitude, and you'll learn all about the stellar magnitude. And if you're lucky, you'll learn about how we tell the distance to the nearest stars or to the farthest stars using something called the distance modulus. Ooh, now that's something else. And then you're going to have to say, then you're going to be confused by what's something called the apparent magnitude, that is the appearance of it in the sky as you see it, and its absolute magnitude, which is the magnitude of the star if it was 10 parsecs away, which is 32.6 light years. So, why do that? Well, there's reasons. We try to standardize something that fights the standards, and that's the universe. Everywhere we look, the universe tells us something different. So we use standards to help do an even comparison. So, trying to do apples to apples comparisons in the universe is really hard, and doing it using some standards, like if we could move all the stars to 10 parsecs, how bright would they all appear from the Earth? That number we based a huge number of other calculations on, things like distances to stars. So if we move, say, certain stars that are very far away and just tiny little points of light in our telescopes to the location to get their absolute magnitude, which is the distance they would be as if they were 10 parsecs away, well, that brightness that we see would actually be, far brighter. And if we took the biggest stars in the universe and we brought them to that location, they would just outshine anything else in the sky by far. So, but that number, those numbers are standards, and it helps us reach a standard to be able to get distance in the universe, primarily. And that's something very important, because we're in a big sphere of black with an occasional dot of light in it, in the stars, and so we have to figure out what those dots of light are doing way out there and what distance they're at, and that helps us figure things out. We can standardize at least some of this. That's what we do, and that's how we do it. Just so you have a background on that. But look up stellar magnitudes, and then you're going to learn, like I said, absolute magnitude, apparent magnitude. If you want, we can do a cloudy night stream, and this is a query question, a cloudy night stream on magnitudes, stellar magnitudes, and we can go through that if you like. Now, Amanda,
I think that would be a good idea. I've already asked Daryl to make a note of this so he can help me with it later, and smart people in chat, they're saying, well, Daryl said that the brightest natural object in the sky after the sun and moon would be Venus at about -4.
Yeah.
A really bright man-made thing is an iridium flare, which can reach -8 or 9.
Yep. And those happen all the time. I've seen several. In fact, while I'm doing this, the SkyTour, I've seen, a number of flares, iridium flares.
Really?
But I can't show
Point
them
them out when you see.
Well, I can't, because they're elsewhere in the sky. We're looking.
Not in the
And
telescope.
I'm not going to sit there and say, oh, guess what you all missed, you know?
Yeah.
That's not fair. That's not nice. So, you know, I keep it to myself until we make it, make it an actual night when we do it. Now, one of the things that we'll do when I do a piggyback night, where I actually have the camera on the back of the telescope, is I will actually make sure that it's going to be a night where there's going to be some iridium flares we can see. And then I'm going to take the telescope and point it at the region of the sky, that is with the camera on the back, where the flare is going to happen. And then we'll see the flare happen live. You'll see it, brighten up, and you'll see it dim out, and say, there it is, the iridium flare, ta-da. Really cool. I think that'll be, I think that'll be really great.
Well, yeah, I was going to say, Prow said recently there was an ISS pass that was -4.
Yep, the ISS can get pretty bright too. It depends on the angle of the panels to the Earth, because they're very reflective. That's right. Yeah. You guys.
Well, because I was going to say something
so
like.
Smart. I love it.
I know, eh? I was going to say, like, the brightest thing I think we look at is probably the Cat's Eye Nebula. I mean, Vega's close. I love Neptune. It's not as bright just because it's as far, and I know that's a factor in this, but
well, the Cat's Eye,
I guess
we have the help.
Well, the Cat's Eye is not ever going to be brighter than Venus, right?
No. In fact, it only looks bright as it does because it's so far away. How's that for an interesting contradiction? If it was closer, it'd be so distended that you wouldn't really see the brightness like that. It doesn't get brighter as it gets closer. It actually gets dimmer because it's getting spread out.
Because we're seeing too much of it.
Well, yeah, it's like if we lived inside of a nebula, then we would have just sort of a hazy night sky. But someone far away might see very sharply defined, areas within the nebula that we are actually living in, and they would think, wow, man, that nebula is so bright. I'd love to live there. But all it would be is it would just block stuff for us to see further out. It would be like a hazy sky, So, I'm glad we kind of live at the edge of a spiral arm in the galaxy where there's no real nebulae that are in our way, because it gives us a chance to actually see out there. Otherwise, we might be fairly isolated in the galaxy. We wouldn't really have a whole lot of knowledge about the rest of the galaxy because we wouldn't be able to see it so well. I'm just going to take us to another object real quick.
Well, before you leave here, Ronald wants to know, again, this is the Wild Duck Galaxy? Yeah.
Wild Duck Cluster. Wild Duck Cluster.
Cluster, that's what I was looking for. The Wild Duck Cluster. Ronald wants to know, how do these stars interact with each other?
That's the thing that's interesting about this whole cluster. And I was going to mention it, but I wasn't going. I decided not to because I didn't want to go down that path without being able to say too much about it, because then people would have to, they'd have to be able to get something they could cling to and say, oh, I understand that. Well, here's what happens. When you have two objects interacting with each other, we can figure out that physics. It's fairly straightforward, okay? When you have three objects, then you have these three objects that are interacting. More tricky, but doable. 4 objects becomes very tough. 5, 6, 7, 8, 500 objects, okay, becomes very, very difficult to figure out all the interactions. That's called solving like if you solve with 2 objects, it's called a 2-body problem. With 3, it's a 3-body problem. When many objects, it's called an n-body. N as in November, n-body problem. And the n-body problem is something that is very, very hard to solve. It requires iterative solutions, iterative calculations, trying to figure this out. Not an easy thing.
And like never ending.
Well, the interactions are ongoing, aren't they? And that's I think your point. They're ongoing interactions. They keep going for all time, unless the cluster disperses itself.
I think you tried to explain this to me. I don't know if you used that terminology, but didn't you say there's 100 atoms? You have to work out from this one atom all 99 other interactions, and then take the second atom and work out the other 99 other interactions, and so on and so forth for all 100, and it just
Yeah, I didn't
And that's
say
only
that to you.
100.
That wasn't me, but I do know that is something we would consider. That we do have to consider. Now,
Yeah. Well, I don't think it was a cluster we were
Yeah.
talking about, but something like that. Just how easily it gets from simple to beyond
yes,
complicated.
that's right.
But,
That's right.
yeah. And that's why things like, you know, -5 is brighter than 2. I don't know. That's.
Seems
I mean,
strange.
I have problem with just simple basic math. Then you're talking, you know, pretend numbers and theoretical situations and
10 numbers.
things that don't exist in the real world that you have to. Again, crazy. You're coming up with formulas to explain what you can't explain otherwise.
Yeah, well, that's true.
I don't know if that sentence made sense. Never mind.
No, but
But-
I understand where you're going with that. I do.
Like, I just think it would be easier if everything was in, like, even numbers or everything in sums of 10 or something like that. But then you take, you know, the Earth rotates every 24 hours. Or, am I saying that right? Not rotates. Revolves?
Yeah, it
Rotates, yeah. Rotates every
revolves.
24 hours and revolves every 300.
Well, orbits
So,
every 360.
right there goes the whole.
Right.
Yeah, so you can't say things can be just as easily tens, groups of tens, or even numbers, right? Because
Right.
the universe doesn't
The
have to make
the universe
sense
doesn't work that way.
on
but,
our behalf.
but there's something that we do.
Yeah.
But it is, again, it's reaching for standards. And one of the things that we do in astronomy is everything has a temperature. Okay, we're looking again at the Dumbbell Nebula. Now it's a moonlit night, so it's kind of washed out. We don't really have a very good color rendering of it because the blue is overwhelming the very faint red. But that's because the dumbbell's not terribly far from the moon, really. We can see a little bit of the red, but if you notice this, okay, well, we look at this and we ask ourselves, as astronomers, we say, what is the temperature of everything in that view? Well, first of all, we have to define what temperature is, okay? Temperature is something that's based on pressure, all right? And there's a law called the ideal gas law, which is pressure times volume is equal to N, this number, times R times T, which is temperature. So PV equals nRT. It's an equation that I'm probably making several people in the group go, oh, I remember that equation. Jeez, wow. That was the ideal gas law. Well, anyway, that one equation gives you some interesting relationships right there. It tells you that as the pressure goes up, the temperature on the other side has to go up for the equation to stay the same. Okay, so and if the pressure goes up and the volume goes up, right, then the temperature goes up drastically. All right, because it's now dependent on P times V. All right, now you don't have to think about this too far, but I have a point to all this. Basically, temperature can only exist where there's some pressure, some measurable pressure. That is to say, some measurable density of a medium within which you can get interactions between atoms that would generate some temperature. Now, we're looking at the Dumbbell Nebula. The Dumbbell Nebula is in the cold vacuum of space, in the areas around the dumbbell that are dark black. Okay, ignore the blue. Dark black, okay, normally. These areas don't have a definition for temperature. There's no temperature there per se. But inside the nebula, it's a special environment. It's an atmosphere of sorts. It's a density, a medium, with some atoms per square meter, or square centimeter that can be measurable, and thus you can actually gauge the interactions between such atoms and assign some temperature values. So you can actually figure out, for instance, what the temperature of a nebula may be at certain points. Yet temperature doesn't really make that much sense to us when we talk about it, in regard to a nebula like this. Now we look at the stars. Well, the surface of the sun is like around 9,000 degrees. Okay, well, but but the star is just it's a ball of hot gas, right? But it has some density, and it has atomic interactions going on, atomic excitation going on. There is conduction going on between atoms, where the energy from one atom gets transferred to another atom in the solar atmosphere. So we can measure a temperature. It's defined there. It can be defined there. Now, when we look at this nebula, for instance, we say, okay, well, it has a central star. That central star is one of the largest white dwarfs, as it turns out. We know this now from previous sessions, in existence. And that white dwarf is actually very, very hot. And it's radiating high doses of radiation out into this nebular gas, where it's then causing the atoms in that nebular gas to interact with this radiation because it's so energetic. So what happens? It increases the atoms absorb some of this radiation, and thus the electrons in those atoms kind of swell up. And when they swell up like this, they absorb some of the light. Okay, it's like you inhaling air. You inhale a breath, and now you're holding your breath. Well, okay, now if you're an atom, when you inhale like that, you're actually absorbing some energy. And then what happens after you've done inhaling? You go, you let it out. Well, the atoms do that as well. It's sort of like, if you want to liken it to breathing, it's similar to that. It's a process where you take in something, you let go of something. So atoms take in this energy, and then they let it out. And when they let it out, they emit light. And the color of the light we see from these types of nebula tells us what kinds of temperatures had to have been in that gas to cause those electrons to rise up like that. I say temperatures. It's energy. You know, the radiative energy, the radiation from these from these things, from these central white dwarfs, have such energy that will cause the atoms to absorb this energy. So, in a sense, you know, when we talk about things like this, we talk about absorption and emission, right? So the atoms in this gas are absorbing energy and then emitting light when they give this energy back and they release this energy back. It comes back in the form of light. And depending on the color, we then know what this nebula is made of. And we know in this case that it's oxygen, which is doubly ionized oxygen, which is O3. All right, and we know that it's singly ionized hydrogen, which is H2. Remember, I talked about the O3 as being doubly ionized, not triply ionized, because O1 is just regular oxygen, okay, with the base energy state. When you go to O2, well, then that's Roman numeral 2, not like the numeral 2. So that's a ionization state. So that's your elementary high school chemistry there, you know. But for those that have forgot it, it's just a way of saying that there's different elements and chemistry going on in these clouds, and they absorb radiation and emit radiation, and thus gives them a characteristic color. But when we talk about temperature, that doesn't give us much here, because the white dwarf is tens of thousands of degrees on its surface, yet it's radiating radiation energy that is, you know, heavy duty in the ultraviolet, and that ultraviolet radiation is energetic and causes the interactions with the particles out in the cloud. But because there's a density, we could figure out a temperature in this gas cloud. But it looks dense here, doesn't it? It has this sort of, it looks like it's dense, especially just below and to the right of that central white dwarf there. It looks kind of like a chunky, dense area. But the fact is, if you were in it, you wouldn't even see it. It'd be all around you, and you wouldn't even know it. All right, like a regular, you know, it's actually more diffuse than a cloud in the sky. When you go through a cloud in the sky, you see these white clouds. But if you know, and the white all around you with no sunlight getting in. But if you go into one of these nebulae, it's light years across. So you're gonna see no particular nebula anywhere if you go to this thing. But because of the density, you're gonna have, you could define a temperature in there, but we don't. But in astronomy, again, reaching for standards, we wanted to have a temperature scale. Hold on. We wanted a temperature scale that we could use that wouldn't confuse us. So we wanted a temperature that started at 0 and went up. And we wanted the lowest temperature of the universe to be 0. And we call that absolute 0, of course. And that scale became the Kelvin scale. All right. And if you want to convert to the Kelvin scale from from centigrade or in Celsius, all you have to do is take whatever the Celsius scale is, all right, and subtract 273 from it. And then that is the that'll be the Celsius equivalent of the Kelvin temperature. So 0 degrees Celsius is 273 degrees Kelvin. All right. So the freezing temperature, is 273 Kelvin. All right. Absolute 0 is minus 273 degrees off of the 0, and that's, you know, minus 273 degrees Celsius is absolute 0, which is 0 degrees Kelvin. And that there's no -1 Kelvin, there's no -10 Kelvin. It's just 0 on up. That makes it easy when we're trying to talk about temperatures of stars and temperatures of plasma and so forth. We just have to deal with the Kelvin scale. And the fact is, the Kelvin scale is the astronomical standard scale. We don't talk about Celsius, we don't talk about Fahrenheit, we only talk about Kelvin. So when you're reading about, like, say, the temperature of the surface of a star, make sure you look for the K after that degree number, and make sure that it's a K for Kelvin. And because if it's a C, it shouldn't be a C, it should be a K. And it'll never be an F, you know, unless they're trying to make it like something that I might do, to say to you, well, you know, the surface of the sun is just about 10,000 degrees. Okay, I would say that in terms of you know, Celsius or Fahrenheit to make it easier to see. Just like when I say, can you believe it's 10 centimeters long? Well, 10 centimeters, you have to figure out in your head, what's 10 centimeters? I don't know, you know. So we're not used to using that kind of terminology, so I have to put it in things that you will understand. But so there, that's a kind of a little bit of a diatribe on the temperatures of nebulae and the scales of the temperatures that we look at, and versus stars and so forth. But hopefully that is reasonably helpful when you're talking about you know, the temperature of space, basically, because there's no real definition for the temperature of space except in areas where there's density, like I said.
Well, okay, when you said, like, to the sides where it should be black, would that be 0 Kelvin?
Well, yes, exactly. That's what I'm saying. Where it looks, where you see no nebula, basically.
That is 0,
well,
and then
you would, yeah. I mean, that's an approximation, because, you know, we don't see other stuff. There might be some dark nebula in there somewhere, and there might be some other matter, some dark matter in there that's dust grains or whatever that's heated up. But yes, most of the time, in the blackness of space, the black emptiness of space, the temperature is going to be absolute 0, typically.
Okay, so am I right to assume the blue? Well, I don't know. Do you still use the phrase hotter when you're talking about temperature in space?
Well, see, welcome to astronomy.
The blue would register higher on the scale than the red at the edges?
Well, that's the thing, okay? Not necessarily.
I don't know how to phrase it.
Yeah, not necessarily. And the reason for that is one of understanding emission nebulae and planetary nebulae. The colors that we're seeing are the result of the atomic interactions, what energies they absorb from the ultraviolet radiation that's radiating through them, and what energies they then emit. And it turns out that atoms of a certain kind will absorb and emit in certain ranges of frequencies, which translates to color. So when we see a red nebula, it doesn't mean that it's hotter or cooler than a blue nebula. In fact, a blue reflection nebula may not be very hot at all. Okay, there's different kinds of nebula. All right, the nebula like the Pleiades have around them, okay, are the result of these B stars illuminating and reflecting light from dust grains that are around these stars. The stars are the stars are embedded in these dark, dusty areas, and so when they are illuminating and light is passing off of this bright blue stuff that we see, well, we're just seeing it as a reflection. So that doesn't mean that it's hotter than a red reflection, or let's say a red light we're seeing. It's just that a red, it's most likely cooler, in fact. A red nebula is from ionized hydrogen. How do you ionize hydrogen? You ionize hydrogen by putting a lot of energy into it. And if you put a lot of energy into a dense gas, it's going to heat up. And that's the whole thing that we're talking about here, you know. So if that's the case, and so taking it a step further, this has been a confusing point, I think, for a lot of people when they learn astronomy. When they start thinking that colors indicate temperature, like on the star diagram, and they see the OBAFGKM, and then they see a red nebula and a blue nebula, they think maybe those are two different temperatures. In fact, they don't have to be, because we're just looking at the properties of atoms that are causing these colors in one case, and we're looking at the properties of the temperatures of the stars, which are causing the colors in the other case. So, and learning to know the difference is part of what astronomy is. You learn about, you know, like planetary nebulae like this. These are, by and large, these are cold regions. But the temperature, okay, is something that is, if you want to say it's warmer than the blackness of space, well, it is. Because the ultraviolet radiation that's impacting the medium, that is these very widely dispersed atoms in this cloud of gas, if you want to call that a medium as a whole, it's going to be a warmer temperature, if you want to measure temperature at all, than the surrounding blackness of space. So I don't know if that's helping you or not, but that's you know, pretty much the rule of thumb there, if you understand.
Well, kinda. I don't know. Hearing those facts about this, I don't know. Maybe I'm sure I've heard them before, but like somehow I feel like maybe I'm understanding a little bit more. Or I think I am anyway, and it makes me very, very happy. Like when I finally click and understand. But
well, see, I use you as a sort of a bellwether. If you're seeing something, then other people are seeing something. Okay, and that's important, because I know that we definitely want to be able to, I mean, I definitely want to be able to show you things that you've never seen before, and then explain them if you don't know what they are, and then let you ask questions about them. You know, I think that's great stuff. You know?
That well, it's a dream come true for me. Anyway, I think a lot of people are very, very grateful that they found your channel through whatever avenues they found your channel, but and that's the thing, I mean, you can Google these images, you can look up this research, you can investigate whatever you want, but having someone to actually say, well, we can actually see it, let's go look, and answer,
I know, that's fun for me.
And explain, and provide analogies, so even the layman can understand, you know, that's more appreciated than you'll ever know. And even the people that do know what we're looking at,
yeah,
just for them to help in and be part of it. I mean, wow, you know how I love this community, but
yeah, you're definitely you're telling me, you know, you're clear. You're very clear. I'm moving to another object, by the way.
Okay, well, so, okay. the middle star is a dwarf star?
Actually, it's a white dwarf. Yes.
A white dwarf, okay.
Yeah.
And you said, like, it's breathing in and breathing out, so to speak.
Yeah, I mean, if you think
It's
of it,
breathing in light
it takes in energy.
and energy. From where? From...
The white... Well, okay. The white dwarf star is providing energy. The nebula, the atoms in the nebula, are what are doing the quote-unquote breathing that I'm talking about. Okay?
Oh, okay.
Yeah. It's that I'm talking about. I'm not talking about the...
So the blue is almost inhaling energy from the white dwarf.
Yeah, I mean, it is. That's the whole...
Okay.
That's the whole point.
And then it's exhaling light, which we see as blue?
Yes.
Kind of?
Yes.
Okay, so then... And then the red is what? Different element processes? Or just it's so far out, it's starting to cool?
No.
Before changing the color?
See,
No?
Don't
Okay.
make the mistake of thinking it means temperature. Again, it means the different element is in play. So that's hydrogen out there.
So hydrogen.
Right.
And the
causing
blue
that.
is the oxygen?
The blue is the oxygen in this case, yeah. It's greenish
It,
blue, yeah.
But just in this case, not necessarily for all
That's correct.
nebula. Okay.
Although...
Okay. Getting there.
Yeah, you are. But for this particular object that we're looking at, that's also true. Okay?
Okay.
And let me just get there.
I have a guess. We haven't zoomed in on it, but I don't know why I have a guess.
There it
I'm
is.
just thinking might be possibly blue and red.
No,
Is it going to be possibly ring-shaped?
no, this isn't the Ring Nebula.
Oh, okay. That's right.
Good call, though, because it's nearby.
Yes,
Well, not nearby, but it's actually pretty interesting. Let me drop the... I'm going to drop the sensitivity down a bit to, say, 1250. Now let's zoom in again. Oops, sorry. I hit the wrong button. Let's zoom in again. Okay.
But we are going to a nebula?
This is a nebula, yeah. This is definitely a nebula.
Well, I see something. I see a second something
Well, you see a star
in
in
the
here, yeah.
top right.
Yeah, that's a
Just
star.
a star. Okay, so it's not like a cluster, double star
Mm-mm.
everything.
Nope. But this is actually the Cat's Eye Nebula.
See, Daryl said that, but he said Cat's Eye Saturn Neb. Ghost of Saturn. What is this? I don't remember hearing this before.
Saturn Nebula is over on the side of the moon. It's going to be really washed out tonight. This is over in near Ursa Major, so this is actually a little better to see. Now let me just take a short exposure of this, because long exposure doesn't really work too well with these because they're so bright. Again, because they're far away. I mean, this particular nebula, all right, is literally it's 3,100 light years away. You know. So let's take a look at it and see, because again, in the center of this one, we also have a bright white dwarf that's in the middle. And I can't really see it too well, and the reason I can't see it too well is I accidentally hit my focus, because I'm an idiot. So I apologize for being an idiot.
You're working in the dark.
Yeah, well, you know.
I'm surprised you don't injure yourself nightly.
I've actually smashed my head into the telescope, you know, a number of times, really, really hard. And I just
don't doubt it.
had to roll right over it because it wouldn't make any sense to say to you, I smashed my head.
Well, unfortunately, I can't do CPR over.
That's okay.
Over Skype.
CPR from smashing my head is not the issue, you know.
Well, first aid, depending how hard you hit it, if you.
I'm focusing this thing now.
Well, speaking of telescopes, Ronald had a question.
Sure.
I'm getting 1,000 mm, I guess millimeter lens for my Pentax DSLR.
Okay.
I have the KR model. Any thoughts on this lens?
It's 1,000 millimeter for his digital. It's for his uh, uh, single lens reflex camera, digital single lens.
Pentax DSLR. He has the KR model.
Pentax digital single lens reflex camera. DSLR.
Okay. And KR model.
KR model, yeah. The 1000. What's the f-stop range for that lens? When I ask that, I mean, you know, when you talk about like the f-stop range, basically what you want to find out is how fast is the lens. In other words, how fast can it acquire light? Because some of them can't acquire light too fast. Others can do like very fast. For instance, I have an f2.8 300 millimeter lens, which is a very fast 300 millimeter telephoto, basically. If he has a 1000 millimeter lens, that's typically it's probably going to do like an f5.6 or f6 f-stop, meaning it's not going to be fast for doing nighttime photography of the sky. But if you're doing time exposures on a telescope, then it'll be fine. You know, I mean, I just don't know what he's got. What you're doing for that, I don't know. I don't know. You got to help me with that.
Okay, well, I typed in chat, so he'll get back to me, and I'll get back to you. There was conversation going on about it. I think Daryl and Andy were giving us some tips, and if anyone else was, I apologize if I didn't catch your name. He also wanted to know, what would it be like to fly through this nebula? Would there be any resistance?
You know, that's kind of relates to what I was talking about before. I'm just going to move a little bit over to the side so I have to do one thing here.
Oh,
but
down to f1.6, I think I saw on one of them, but normally running f6.
Yeah, f6. Yeah, that's what I thought. And if the lens can go down to f1.6, well, that's there's really very few lenses that can do that. That's pretty good. I'd like to know more about that lens if that's the case. What who makes it? Because I know that I have a f2.8 lens, 300 millimeter, and that was $3,000. Because it's very fast. You're paying for the speed of the lens, which is kind of a weird thing.
Yeah, I wasn't. I was kind of. I was listening to what you were saying. I wasn't paying too much attention to the conversation.
Okay.
In chat, because I don't really know anything about cameras or telescopes or anything. So
well, that's
I figured the people in chat knew what they were talking about, but I wanted to get your opinion as well. So.
Well, how do you know they know what they're talking about? Because they're smart. That's why.
Haha, because they've never let me down yet. That's how I know. I trust the people in chat. Smart. They have wrenches for reasons.
No, we have very smart folks that come in with us and join us, and I'm very, very pleased.
Oh, I'm blown away. Every chat, it's unbelievable. And a lot of them, it's like they can read my mind. Before I ask, I'm seeing little pop-ups and...
Oh, that's funny.
It's awesome. We love you, chat.
Very funny, very funny. Alright, I'm just going to go back to our object now.
And they all wanted you to know, since the beginning, you didn't, although you acknowledged it being the 1st of October and 27 days until Jigsaw, you still haven't changed the date on the screen or in YouTube.
Shoot, I meant to do that, guys. I am so sorry.
With YouTube, I don't really care with YouTube. You can go back and change it after, but on the screen, yeah. They mentioned it right from the get-go, but...
Yeah, I did make that mistake.
If that's the word happens tonight, it's a good night.
Yeah, I mean, we're not having any buffering issues?
Ronald was. I think it may his system, though. And I think one or two mentioned a glitch here or there, but every time I go back to check, Mark's sharing screens with me on Skype, so I can actually see this live time and comment live. But anytime I see it, which isn't often, it's not often, okay. But I'll go back and watch it on YouTube for a while, and I'm fine here, so.
Okay, cool. Very happy with that, then. Let's see here. I want to do something.
Oh, and it's buffering. I just went back to YouTube to check.
Now it's buffering.
Hi NSA, I love you. They're mad because I left them out. I was gonna acknowledge them, and I should have.
Yeah, I'm not too worried about that. Okay, now I know it looks like a dim picture, and that's partially intentional. I want to try and zoom in on this.
Mine
object.
says it's been buffering.
Is it still buffering?
Okay. No. It looks like it's good now.
Okay. I gotta go a little more.
20 seconds behind, actually.
What's that?
Only about 20 seconds behind, actually. It just went to 42.
Oh, okay.
20. And it's 35 on yours, so.
Okay.
Not bad. It's digression, sorry.
I had a friend come up. He was here 2 nights ago and the night before, and he stayed for a couple days. And he works for the NSA. He's actually an NSA employee. So.
Really?
Yep. Yeah, and he used to work for me here in my shop, actually. So we
I'd
had.
like to be friends with him.
Huh?
I'd like to be friends with him.
Oh, he's a very good guy. He's a really good guy. He's just he has a very dry sense of humor. You know, when
Yeah, you bet.
he greets me. He goes, "Dark Lord," and he gives me this little salute. You know, it's like it's like Jesus.
So don't say that on air. We're gonna crash.
Not at all. No, it's just.
They'd
fun.
love me. I want to work for whatever the Canadian version of them is.
Well, maybe the Royal Canadian Mounted Police.
No.
No.
No, thank you.
See, why are they so bad?
They're not. My cousin's a Mountie.
Okay, so why do you say no thank you? Is it like, are they not good?
No, they're the best of the best, actually. No offense to the RCMP at all.
Okay.
Oh my goodness. No, I don't know. I'd rather get real bad guys.
Oh, they don't?
I'm thinking bigger. Yeah, but it's.
It's interesting.
I mean, people that spend the weekend learning how to make bombs.
Oh, yeah.
I want to get those people.
Yeah, I've actually worked
not
at
just criminals on the street. We have the RCMP. They're doing a wonderful job. They don't need me.
Yeah.
I'd probably end up getting shot. So, but yeah.
Well, I would hope not.
I would hope not either.
Yeah. Okay, let's see here.
The Canadian Security Intelligence Service.
Okay.
Yes.
Yeah, I'm trying to refine my focus here, guys. I'm just trying to, it's just with a bright moon, it's actually kind of hard. So I'm going to abandon what I was looking for on this particular nebula, and we'll have to come back to it when it's darker out. Of course, on top of it, my feet are frigid, so I'm trying to do this while I'm freezing. So let me see here. Next object.
If someone gives you coordinates, would you be able to see it, or does it have to be like basically in your area?
Well, I mean, if it's not in the area, then we're not gonna be able to see it.
Mm-hmm.
I'm moving up to something right now, by the way.
Mm-hmm.
Won't be long. We're almost there. One of the first double stars I ever looked at in my life was this one. And this is an incredible double star. It's called Epsilon Lyra, and it's right near Vega. Epsilon Lyra is let's see, 160. Let me see. Let me remember. 162 light years. And the interesting thing is, this double star is actually more than just a single double star. And I want to show you, if I can. I might have to do it photographically, but let's just see. If I zoom in, right, It's going to be a little tough to see here.
Uh-oh.
What?
Buffering again.
Oh, is it?
Yeah, for a few people.
Okay. I'm going to drop this down to...
Back.
Thank you. Come down here, and I'm going to go... This is 800...
See, unfortunately, until Mark gets his new modem, which I think is going to be pretty soon, there's not much we can do about... Pardon?
Yeah, any second now. It's supposed to be here pretty quick. Okay, you can just barely see them here. These stars are actually double doubles. Each of them is a double star in its own right, and it's just a fascinating pair of stars and another double pair of stars. And I probably could spend some time working on the focus a little bit, but I think part of it is I'm so cold that I'm not able to, you know, feel my fingers fully, but that's okay. Anyway.
I saw the little mitten too, your little glove.
Yeah, I was wearing gloves. I am. And the weak link is my socks tonight. My socks are not wool. That was a problem. I'm going to drop this down to 250, and I'm going to go up to half a second. Let's see what this gives us. Now let's zoom in and check it out.
Your music got loud.
I didn't turn it up. You turned it up. It must have been you. Oh yeah, see, I'm not even focused here. Okay. Let's try this one last time. Yes, it is. Oh yes, I am.
And Pry wanted to know, can you see other dwarf planets other than Pluto?
Unfortunately, no.
No, why not?
Because
are they all too far away, or?
No. I mean,
how many other dwarf planets do we know about? Are there?
Well,
lots?
we have. There's several thousand actually, but with the brightness of the moon tonight, I don't think we'll be able to see any.
Can you normally? Would you be able to?
Oh, absolutely. Yeah, no, they're just.
Okay. Well, that's okay.
Those are known as asteroids. You know, the asteroids are dwarf. I say dwarf planets. They're actually, you know. When you talk about asteroids, I just saw a meteor. It was amazing, and see, I'm calling it out, and you guys couldn't see it, and so I feel like a real schmuck for mentioning it.
Oh.
Yeah. Sorry.
I'm sure I saw some birds flying by the moon. So if anyone has any interest, you can go back after this is uploaded.
Oh, is that right? Is that when the was it?
I'm sure.
While we were streaming, though?
I saw a few things. Yeah. We saw a ton of them last night at P&K Space Imaging.
Yeah, they were.
But I'm sure I saw a few little flutters go by.
Yeah. Yeah, the other problem is, believe it or not, in this cold, I'm actually getting dew on the lens. So, part of me wants to drag out the hairdryer and aim it at my feet, but, you know. Oh, we're gonna. Let me see what we got on the lens here, on the not the lens, the corrector plate. Turn on my light, you might see a red glow. Oh yeah.
Okay, can you see stars in Iowa?
Huh?
Can you see the sky above southeastern Iowa?
What do you mean? Not
if I gave you coordinates that pointed over there, would you be able to see anything from where you're
southeastern Iowa?
Yeah. IOWA.
Yeah, no.
Am I pronouncing it wrong? It's Iowa. Okay,
the state of Iowa.
Sounds like you've never heard of what I was talking about before.
Well, not asked that way. I mean, can I see the skies above Iowa? I mean, that question doesn't really It doesn't make sense to me. I'll tell you why. And I'm also trying to put this dew cap back on the telescope, and my hands are.
I thought you were gonna say I'm trying to break it to you gently that it's a
No.
ridiculous question.
No,
How
no, no.
do-
It's
do-
just,
do
it's
you
a,
feel
it's a
about it?
question that is kind of hard to answer because the skies of Iowa are, 1,000 miles west of me, and I mean, if I have to aim to the west, I mean, I'm aiming my telescope. This telescope's aiming to the west. In Iowa right now, the stars that I'm looking at that are in the telescope, Upsilon Lyra, may very well be more overhead for someone in Iowa right now. So I mean, I don't know how to answer that question because we're looking at
I
the
know.
same sky from Iowa or here.
I know, but I guess
Is that your question or someone
how
asking you?
low in the question? Well, no, someone put in coordinates because they're trying to figure out what they're looking at in the sky. But I don't know
Oh.
how high up in the sky is because it's ground coordinates. So
Okay,
I'm thinking like
that's
if it's
actually-
something low in the sky, no, you're not going to see it. But
That's right. That's
do you know what I mean?
That's a logical question. You added that addition to the question. Makes
I know.
more sense.
I know.
That's okay. No, that's fine. That's fine.
And Daryl's guessing is probably Capella. If it is, would you be able to see that?
Well, Capella's in the northeast right now. I mean, I'm looking at that. I can see Capella.
So I don't know how high things are and how washed out things are going to be because of the moon. I mean, I could give you her coordinates from where she is.
Okay, well.
But apparently that's her ground coordinates. So,
right.
like, if you knew her area, would you know what is in the sky above her right now?
Yes, I could actually tell her what's in the sky above her, but I'd have to get out of the streaming and I'd have to go into like my my astronomical program that I use, and that would show us.
Okay.
But Capella is actually. Let me see if I can. Let me see if I can add something here that might help.
She said it's, I guess, northeast,
Okay.
really low, and flashes a lot. Does that sound like Capella?
It sounds like a star, because stars flash a lot when they're low of the horizon because they're just point sources. Planets won't do that. Planets tend to be fairly solid in their view, in their look. Okay. I'm looking for something here to help.
Okay. Oh, it's in Auriga.
Auriga, yeah, that might be.
Auriga the charioteer.
Yeah, it's probably Capella then.
Oh well, I don't know. I don't know if maybe Daryl put them in somewhere and is searching, or if he just happens to know this offhand. I'm not sure.
Auriga's actually rising. Now it's in Auriga's in the northeast, and if you go farther west, okay, then Auriga's gonna still be fairly low in the sky. So it's going to look like it's near the horizon. Capella's going to look like it's near the horizon. Capella's yellow. Ask her if it's a yellow star or yellow object, and she'll probably say, well, it appears to be, more yellow than any other color.
Don't lead her.
I'm not. I'm just going to ask her what the color is, but she's here.
I did. I said, I asked if it was yellow.
Okay.
And Daryl was asking her if she could see 3 stars near it, probably thinking Orion's belt, maybe.
No. She's asking. He's asking if he can see the 3 stars that are near Capella, which are the well-known little stars that kind of isolate Auriga or Capella rather, from the rest of the sky, and that it has this little entourage with it. He's talking about probably Alance, Hades, and Rho Auriga, which is nearby. Those are the 3 stars, by the way. They're
Okay.
hanging out.
Yeah. Well.
You know, when I look at Auriga right now, you know, those 3 things are there. You know, is this too bad? You know, it's too bad it's a moonlit night because right now the Orion Nebula is. I'm sorry. Right now, Andromeda Galaxy is directly overhead. But I'll show you. I'll show you what it looks like.
Well, speaking of the moon and the imagery, we have a question from Keith of P&K Space Imaging. Anyone who hasn't subscribed and hit the bell, please do so.
Yeah,
He
do
is
so.
now in
P&K
chat.
Space Imaging, my other favorite place to be.
Okay, and just a secret between all of us on the channel here. He's cheating by asking this question here. He's bringing the answer over to his chat room. So even the great astronomers over at P&K still come to Mark.
You dirty dog, Keith. Nah, it's okay. What's he have?
Say streaming on a Sunday night. Game of Thrones is over. Anyway, sorry. Would a wider debris pattern be caused by a slower, larger meteor compared to small debris patterns for faster, smaller impact?
Well, okay, the problem is that when you have impacts of any notable size, you get what I talked about actually yesterday on P&K, I think it was. You get liquefaction of the soils, and it makes it appear it appears to run like water, okay? But it really isn't running like water. You're just getting that liquefaction effect. So when you have an impactor strike the moon, like one that hit Copernicus, okay, that created Copernicus, and we had someone ask about Copernicus yesterday, and I discussed how the shape of the debris apron, that's called, around the crater was characteristic of liquefaction of the soils, the regolith, the lunar regolith around Copernicus, and thus it looked like it flowed out like water. But that's because of the impact, the vibration, and the shock wave. When that did that, and when it hit, it actually does cause that appearance, and actually causes the soil to run like water for a period of time, for a few seconds, and then it's over after the impact, and it freezes that way. And in the same way that if you want to see how liquefaction works, you can fill a bucket with sand and put it on a shake table, and then set something that sits on top of the sand, like a shoe, okay? And if your bucket's big enough and you shake that table, you can watch the shoe just sink right down in the sand like quicksand. All right? And that's because of the liquefaction. You know, the soil is moving from the vibration, and that vibration will cause it to sink. So when you ask about whether the impacts can cause that, well, they do. They always cause that. They can cause that in varying degrees. Like, and we talked about Tycho versus Copernicus. Tycho, that impact occurred in the highlands on the moon, and so any liquefaction was broken up, and the energy dissipated through all of the highland areas where the impact occurred. And so you didn't get that kind of area like you do in Copernicus, where it's out in the middle of a maria, which is generally fairly uniform, and I'll say it carefully, homogeneous, homogeneous soils out there. So when the impactor struck, this blast wave, the shock wave, moved out through the medium of the moon itself and created these ripples, basically, in the lunar soil, which are the result of the liquefaction. Now, in Copernicus's case, the density of the area around it was fairly similar, so you have this kind of cohesive apron of debris that looks like a water strike, like a watery type crater strike. We see this on Mars as well, but see, the confusion here is that on Mars it is due from soils that were wet, and they were strikes in what were shallow seas and things like that on Mars at one time, and we can't draw that same analogy with the moon, unfortunately. So I think that as far as the impactor, the impactor of any notable size that can cause a shock wave to get transmitted through the lunar lithosphere, that the crust, the lunar crust, then that will cause some level of liquefaction for a period of time, and then you might see that depending on how the shock wave travels out. As I said, in the highland areas of the moon, like where Tycho is, that beautiful impact, you don't see that, and for some of those craters you don't, but you do see it for some of the craters out in the Maria, like I said, and it's not just Copernicus. I've just used that as an example.
Well, he said, for context, he was actually comparing Tycho with Aristarchus.
Okay, yeah.
And Daryl remembers you guys were talking about Tycho and Copernicus last night, which you brought up again. But
the same thing with Aristarchus.
So Aristarchus, yeah.
Same thing with Aristarchus. I mean,
that's a beautiful name.
Yeah, Aristarchus is gorgeous, and it's also a great name.
Mm-hmm.
And I actually 3D printed out Aristarchus in our craters, and then I painstakingly painted
available for sale shortly.
Yeah, well, if people like it, I mean, I'll be printing out Clavius and Pythagoras over time. I'll get all these craters and, mount them on a block and with a brass plate of the name and the location, latitude and longitude on the moon. And just as an aside, I did that with a section of Pluto, because we do Pluto as well. We have all the data for Pluto, as well as Mars and Ceres and Vesta and Earth even, and Mercury has some. But the Pluto plate that I made up for Devil's Tower UFO Rendezvous, that commanded the highest number of bids and the highest value in the silent auction.
Yeah, well, hold on. Not everyone may have been at B&K last night. Tell them about. They know you went to Devil's Tower, but tell them about the silent auction. Not everyone knew about that.
Oh, okay.
I didn't know about that until last night, actually. I think that was a really nice thing to do.
Yeah, well, what we did was we always like to give back, and what I did was, this was the first time this conference was being done, so I sat down with Bob Olson and Lori Tucker, the people that were putting this on, and before I went out there, I called them on the phone. I was talking to them for like an hour apiece, just giving them pointers about how these conferences work, and they didn't even know that they had to pay the airfare for the people. They just invited people and thought they would just show up.
Well, that's what I would do.
Well, yeah, because people don't know how this works, okay? But once I acquainted them with the idea and saying, look, usually you provide lodging and airfare for these people, and then you give them an honorarium, a dollar amount that you decide you can afford. If you can't afford it, that's fine. You just tell them so. And to their credit, they chose to do airfare, lodging, and gave us money to go do the talks, which is very fair, very nice for the first time. And I told them, don't spend too much on people up front, because you can actually you want to get people to come back. The thing you want to spend your time on is getting the press there, getting the people there, and I have to give them credit. Lori and Bob actually got the UK Sun there, the Sun, which is a tabloid, but they do have some good articles. He wrote a good one on me.
Which led to a question that's going to come up in chat very soon. Keith, if you're still there, maybe we could use the people in your chat. We could for a poll.
Yeah, and that's a question.
Sorry, I digress. Go on with your story. Mm-hmm.
Yeah. So they ended up. They did a whole bunch of television spots. They got TV there. They got television spots. I did a number of interviews. They even had Blues Brothers recreators with the car with the big speaker on the top. I mean, the car down to every little last detail. And these guys even showed up just to for fun. I mean, and it was really cool. It was a very nice event. So for their first time, they measured it as a success. And you know what? That's very rare. That's very rare. They had people flying in from all over the country to come to this conference, this little tiny conference. And next year their conference is probably going to end up being twice as large, because people are going to be coming in from even farther away now that they know the thing is worth it. And I told them I'd come back and do a different talk if they like, But the night skies are just stupendous there, like I said. And I'm getting off the track from what I was saying before, but
Hold on. Well, first talk about the auction, and then we'll pull the audience.
All right, let me just finish Keith's question though. Aristarchus does show that pattern, that actual pattern of impact debris, that apron of ejecta from Aristarchus does show an interesting shape to it. But after having printed it out in a 3D model, I see exactly what it's doing and see exactly where it's going. And that's something that you can get with a 3D model that you can't get from a photograph. The Lunar Reconnaissance Orbiter quick map is wonderful, but you don't get the 3D view. You just get the top-down view, and that's problematic. If you don't know which way the light's going, or if the images are made up of several successive orbits or over different phases of the moon, then it could be a problematic thing. So the 3D model is what really dictates what's going on. And you see the topography, that changes everything. That tells you what's going on. And so I printed out Aristarchus, and I saw how Aristarchus has this preponderance of height to the apron of the crater to the west side of it. And it's really incredible. And so I got out the airbrush, and I painstakingly painted the areas of Aristarchus to show up very bright white. And I chose to make it a very subtle shade of white off the gray. So it doesn't, from a distance, you may not even notice that there's some white on there. It almost looks like it's all gray. But then as soon as you take a flash picture, or as soon as you put it out in the sun, the white areas really reflect the light the way they do for the real crater. So it was a good blend. And so what I'm pointing out with that is that the detail on the moon that we see with this stark contrast that we see all the time, that's not evident, to the eye normally. Okay, what is evident is the dark maria and the lighter highlands of the craters. All right, that's what's evident to the eye. What's not evident is the subtle differences within the craters. This comes from looking at the photos and from the different aspects of it. But when you print out a 3D model, that's when you actually see how the actual terrain goes and what may very well be causing what you see there for the appearance of the crater. Now you said you had another question with in the chat.
Not from the chat. I wanted you to tell them about the auction at Devil's Tower.
All right, I'll do that.
I don't think there was another question. But I hope there.
I'm moving again, by the way.
And then we have a question for chat, and I've asked Keith to pull his people too. But first,
what?
Things first. Ooh.
Yeah, sorry. Bright. Watch your eyes.
Very bright.
Guys. Yeah, it's because I've got it way bright, way turned up. Actually, this is kind of a good thing, because what I'm showing you here is obviously it's too bright, but I want you to notice how when you put it bright like this, you can actually see the stark divisions along the terminator of the moon. I'm also going to drop the ISO down to 64.
To non-retina burning?
That would be appreciated. Well, I'm actually going to change this down to something a little bit more usable. And I'm going to compare. I want to look at one of the craters that I was looking at earlier and see if I have a difference now. Something that... Wow. You literally... You're unaware of it until you actually are aware of it. You look for the differences where a crater might be partially illuminated, and then you look for whether that crater actually ended up being more illuminated by the end of the night. Because the sun, it's inexorably, it's being inexorably illuminated by the sun over and over and over, as it moves through its cycles. And here we have that crater up there in the upper right there. You can see that there's a little bit more of that rim showing, and it's a little bit... Check the focus here. Let's go out and in. Okay, that looks like we're as close as we're going to get. We got some disturbance here. You know what happens is when you're in a dome, your body heat actually generates turbulent waves which end up going out of the slit in the dome. But it's either that or you stand out in the middle of the frigid cold. And I'm getting a cold wind on me right now from all this because it's aiming out the door. It's like, ugh. I don't know how I'm going to do this when it comes time to winter. I don't know how I'm going to do this. But I will. I will.
Wow.
So, okay.
It's dedication.
No, it's craziness.
Well,
Okay,
I was trying to be polite.
Thank you. I'm going to drop us down a little bit in brightness here just to get a little better contrast. Okay. Now let's go back in.
Brr, I just got a shiver down my spine just thinking of winter.
Yeah. Okay, let me just do this. Pull in. Oh.
They're all suggesting electric long johns. From one astronomer to another.
Yeah.
I think he lived up in the mountains for a while too, so...
Daryl was very high in the mountains in Colorado, and I don't mean that in any sense other than he was higher in altitude. So
Liable.
Okay, so... Alright, there I am. I'm there. Yeah, so now we're focused here on Copernicus again. And earlier in the night, you remember I pointed out the Apollo 12 landing site, which is just down here below Copernicus, and then to the right of it a little bit more is Apollo 14's. And when you look at the Lunar Reconnaissance Orbiter site, you can actually look at the sites directly by zooming into them from the far. You can be this, farther than this from the moon, and zoom in all the way down to the sites and see them. So it's really cool to just zoom in over and over until you get all the way down to that location. It's just incredible stuff. Now, as far as the silent auction,
Thank you.
when Devil's Tower, what happened was there was a silent auction and people would donate to the silent auction.
What was it for? What was it raising money for?
It was raising money, for the local charities and so forth. And people donated all kinds of things. They donated movie posters for Close Encounters of the Third Kind because it was the 40th anniversary of the movie. And both Bob and Lori had no idea that movie was being re-released on September 1st, 2 weeks before this conference. They had no idea. So this was just an amazing event because they benefited unknowingly from the fact that this was happening. And then they actually then had a silent auction, and people were donating all kinds of Close Encounters memorabilia and stuff like that. And what we did was we donated a 4¼ by 4¼ section of the planet, dwarf planet Pluto, painted realistically with the proper colors, with the airbrush, and represented on that little 3D model, like we did. We made a 3D model slab of the planet, and we put the latitude and longitude of the center of the location on a brass plate along with the name Pluto. And it was all mounted on a beautiful wooden plaque. And we put it in the silent auction, and people, walk up, and there's like a sheet of paper, and you put your bid and your name, your ID. Mm-hmm. And the list for the Pluto plate on the auction was just long, huge. And whereas other people, bid, $5 or $10 for something, ours kept going up and up and up and up and up. And finally, there was somebody, like 4 or 5 people at the end were kind of in this little bidding war, I guess, and they ended up, one guy finally won it. But it was the thing, of all the many objects and many items in the silent auction, our Pluto plate sold for the highest amount and had the most bids. So that was kind of cool.
That's very cool.
Well, it's a section of Pluto. I mean, New Horizons did a spectacular job. And, I wasted no time getting a hold of that data as an astronomer. I wanted to study Pluto, learn about it, and then, of course, I was tasked with doing a number of stories about Pluto for, What on Earth and so forth. And so um, I had to, have the information anyway. So I was diving into that information, digging around Pluto, and thought, wow, this is just so incredible. This is an amazing, it's an amazing a dwarf planet, And I don't really want to call it a dwarf planet. I fight all the time. You heard me almost say planet before. It's like, it really is. It really is a planet to me. It really belongs in that category. And I mentioned before,
Pluto is too cool to be labeled.
Oh, there you go.
And that's not a temperature thing. I mean, maybe it is. I don't know. Maybe I was unintentionally punny there, but
it is punny because it is very cold.
Well, they thought it was a giant ice ball, but no, it has water and.
Yeah, it has nitrogen ice, and it has an atmosphere. Did you know that?
Yes, because it looks blue. Well, no, you're gonna disagree with me. I heard if you stood on Pluto and you looked up, it would be like standing on Earth looking up. Like, it would look like a blue sky.
No.
You say no.
No.
Why? Why do I always think this? Why do you always correct me?
Because that is not correct. Because there are people on the internet that have just been saying that. Just like they always say, in this August, Mars will be as big as the full moon. That's baloney. That's never happened in the entire history of the Earth. And it's impossible.
But if you look down at Jupiter through its clouds, they're all multicolored, right?
Yes.
Yes. Okay. Well, then, if I was standing on Pluto and I looked up, what color would the sky be? Would I see a sky?
You might see some haze on the horizon, but mostly stars. And the reason is because the atmosphere of Pluto is very, very tenuous and mostly made of the nitrogen that outgassed off the surface of Pluto. So you're not going to see a whole lot at all. And that's sort of the misnomer. People have sort of have said that, well, basically that, this is the kind of thing they're saying is what you see on Pluto, when it's really not. And it's sort of a kind of a little insidious lie that they're foisting on people, because you're not going to see a blue sky. They might have heard an astronomer suggest that maybe you would see, if you took a time exposure, you might see a bit of a bluish haze, okay? Because
what color would the haze be? Whatever, Mr. Haze.
It might have been a bluish haze, okay? But it's not a sky. You're not going to see only blue sky. You're going to see mostly stars in the sky. And near the horizon, you might see the faintest wispiness as you're looking through more of the atmosphere. Because the atmosphere in Pluto is very tenuous. It's not thick at all. And, this object we're looking at right now on the screen, right? The moon?
Mm-hmm.
Do you know it has an atmosphere? The moon has an atmosphere, right? Analysis of the moon shows that there's actually a fairly high quantity of sodium atoms that are surrounding it, and you can't see this atmosphere. You can't photograph this atmosphere, not from Earth. But the moon does have an atmosphere, and it has a number of different atoms in the atmosphere. They're very tenuous. Obviously, there's hardly anything there to breathe, and Mars' atmosphere is only 0.08 that of Earth. Okay, so it's literally 8/100ths, right, of the Earth. But the fact is, even on Mars, you're going to look up and see a salmon-colored sky because of the dust in the air. So, and there are some clouds, wispy clouds on Mars that are carbon dioxide ice. So, you do see the elements of an atmosphere even when it's small. But looking at the moon, it's much smaller than Mars even. It's 100 to 1,000 times smaller than the amount that we see on Mars. So you're not going to see any atmosphere on the moon, even if you're on the moon looking up. You're not going to see a thing. You see stars right to the horizon, But you're looking through sodium atoms, some, I think it's phosphorus atoms, and then there's some others, argon, some trace elements and stuff like that.
Okay, well, again, so many questions. Okay, well, if you were standing on Mars,
Hmm.
even with a slight atmosphere, because of the dust, you might see salmon colored.
Yes, but
Well,
we know
wouldn't
you
the
do. Yeah.
dust on the moon be brown? Probably. Why wouldn't you see a hazy brown?
Because it's the dust, the atmosphere, if you can call it that, on the moon is actually far more tenuous than that on Mars. There's
Is well, yeah, but you
it's
use
far
that word
thinner.
to describe Pluto too, and you
Yes.
might see. Now, is Pluto's dust blue? Like Mars's dust is
No.
red,
No.
going into the haze? No.
No.
Okay.
No. That's because Mars. See, Mars has an interesting thing. Mars has a lot lower gravity than the Earth, of course, and so when the dust gets elevated by the winds on Mars, which, by the way, have to blow pretty hard to actually lift that dust, which is the consistency of talcum powder in some cases, off the surface, because it's not so dense at all. I mean, when it gets elevated, it stays in the atmosphere for a long, long time. So you'll get dust in the atmosphere. Sometimes you get global dust storms that take months and months to go away. So it's fairly interesting.
Does that happen on any other planets or moons?
What's that? The dust storms?
Yeah.
Well,
Or something projecting, I don't know, the color of the soil on that planet or moon into the sky to change the color of the atmosphere. Like
well, no,
Earth sees blue, but it's not because of the dust
no.
from, you know what I mean? So like, how do you
The blue
know?
color, the blue color in our atmosphere, is actually due to uh, well, it's actually a property of atoms. The property of the nitrogen atoms in the atmosphere, they actually take in the full red, orange, yellow, green, blue, indigo, and violet light from the sun, the white light from the sun, broken up into the colors, as you can, that's I just stated, and they literally absorb all of it. Okay, but uh, they emit the blue light in all directions. Okay, and the other stuff just passes through. All right, so that particular process is called scattering, and it's Rayleigh scattering. Rayleigh was a scientist that identified the scattering process. And what is scattering? Scattering is just when the molecules selectively pick a frequency of light and say, "Ooh, I want to just kick that one out." And as they go to absorb the light, they kick out the other light, that they don't want. And because the orientation doesn't matter to them, they just shoot that light in all directions. Okay, so we end up seeing the blue light in the sky because of our predominant nitrogen atmosphere. Similarly, at night, while we look around the blue moon, the moon, and we see sort of a hazy blue nighttime sky. And you saw in some of the photos we took when we took a deep sky photo, it actually looked a little blue, and the reason, of course, was because of the fact that the moon light is reflected sunlight, and the nitrogen atoms are doing the same thing. They're taking this light from the sun, and they are scattering the blue component of the light. Now,
But
that's why our sky is blue. Okay, now.
But that only happens on Earth because of our atmosphere being the right
density.
Yeah.
We can see this because we have a very dense atmosphere. Okay? Now, on Pluto, even though it has a predominantly nitrogen consistency and nitrogen chemical makeup in the atmosphere, it's so tenuous, it's so thin, that you wouldn't look up and see blue sky like on Earth, okay, because there's just not enough of it for you to see. Now, could you photograph it? Yes, we have. We can photograph the atmosphere of Pluto and have the New Horizons probe. And when you look at Pluto, you don't see an atmosphere, okay? When you're approaching Pluto with New Horizons and you see the lit disk of Pluto, you don't see the atmosphere. You only see it when the New Horizons passes Pluto and looks back at it. Then against the sun, backlit, you actually see the atmosphere. That's how you see the atmosphere. When you look at the
Yeah.
Earth from space, fully lit, you see clouds and you can see the blue haze right from space, on the sunlit side, because we have such high density of atmosphere. Pluto doesn't have that. Mars has that as well. Mars has a lot of craters that you can see right from orbit in the fully lit side, but you also see clouds, and you can also see haze at the limb, even on the daylight side, because there's enough of an atmosphere that you can see that. Pluto has far less even than that, and so it's more akin to something more than the moon, and quite a bit less than Mars. So you have this atmosphere of Pluto that you can kind of just barely see, but only when you look back at it through the light. You can't see it when you're looking directly at Pluto. There's nothing to indicate there's an atmosphere there.
Okay, so then focusing on Mars, and I'm sorry to chat if I'm really digressing here, but okay, with Mars, we're seeing red because that's the dust coming up.
Yeah,
What if it was totally still and there was no dust? I mean, it's not the light bending, but I can't describe it as elegantly as you just did, but, taking in the light and rejecting the colors it doesn't want?
Yes.
Is it because of distance, it wouldn't bend blue? Like, it wouldn't keep the blue to reflect?
Yeah, it doesn't bend. It actually, it's the process of scattering is basically just selectively kicking out the light that it can't absorb, or it doesn't like to absorb. That happens with nitrogen atoms, okay, in our atmosphere. So we would never see a blue Martian atmosphere because the Martian atmosphere isn't made of nitrogen, is it? The Martian atmosphere is mostly carbon dioxide. And so we wouldn't see that. We would only see whatever carbon dioxide might decide it doesn't like. But there really isn't anything that carbon dioxide doesn't really like. So we wouldn't see any kind of a scattering process other than whatever the CO2 molecule might reject, and scatter back to the eye. So Mars might have a fairly clean atmosphere if the dust wasn't airborne. But you got to keep in mind that the dust that you see is basically elements of the regolith, the soil on Mars, which is basically iron compounds that have oxygen bind with it to make basically the iron oxide, Fe, the symbol for iron, Fe, and then O2, oxygen with numeral 2, FeO2, which is rust, iron oxide. So the oxygen left the atmosphere and bound up with the rocks, right? And so there might have been an oxygen atmosphere, and there might have been a different color sky based on what the oxygen might have scattered. But because Mars didn't have a magnetic field, or not for long anyway, the protection from ultraviolet energy from the sun just wasn't there after a period of time in Mars evolution. And so most of the water vapor, H2O, water vapor in the atmosphere, was broken apart by this high energy ultraviolet radiation from the sun, that which we are protected from by our magnetic field. And thus the water cycle on Earth can continue because we aren't having water being broken apart by ultraviolet radiation like it is on Mars. So when the water vapor got up in the atmosphere of Mars, it was broken apart. And when it was broken apart, the hydrogen escaped to space. The oxygen, would bind up with compounds down in the ground. So in other words, the oxygen in the atmosphere that might have been ended up being absorbed into ground compounds, and thus makes the rusty Mars that we see today. Hope that makes sense to you.
Yeah, well, I mean, for the most part, I could follow what you were saying.
Mm-hmm.
But, see, again, I mean, I want to ask you about all of the planets. I mean, we can't do it with Jupiter, Saturn, Neptune, or Uranus because they're gas planets. So okay, well,
They have an atmosphere.
Jupiter is multicolored, has multicolored clouds, right? So
Right. Now, you weren't on the P&K stream when I talked about, we had a Jupiter night, and we talked about all the ammonia compounds in Jupiter's atmosphere. Jupiter's mostly hydrogen gas, okay? And I can't look at Jupiter tonight because it's set. It's not up, or I would. But Jupiter's got mostly hydrogen gas for a atmosphere. And there are just a tiny bit of ammonia compounds that are basically contaminants, so to speak, to hydrogen. And these give the brown cloud bands their color. It's very interesting, you know. And so, and then Jupiter also has extremely complex atmospherics going on there, because the white bands tend to be higher up, the dark bands tend to be lower in elevation. So there's three-dimensionality to all this too. On top of it, it's not just a ball painted white and brown, You know, it's got this undulating atmosphere, and those cloud bands, okay, are moving in opposite directions from each other in some cases by hundreds of miles an hour. So right at the border, there's this extremely turbulent region where the bands pass each other. Okay, and you know, there's a lot of what do I call it? Shearing going on there at that place. Now, just to be fair, you know, they call them bands and they call them zones. Okay, the white areas, I believe, are the zones, and the brown are the bands. And where the bands and zones meet, you have this shearing between them as they're moving in opposite directions. This is something that's really incredible, because that shows that the weather patterns on Jupiter that were set up in its formation are the result of some kind of turbulent distress that planet went through early on. And it's just outrageous, you know. We also talked about the hexagon on Saturn, actually, as well yesterday, with I think it was Keith, wasn't it? Didn't we talk about the hexagon? I'm trying to remember.
I don't know. Sorry, I just muted because I think Keith is trying to get me in trouble here.
Oh yeah, what did he do? What's he doing? What's that boy doing? Okay, I guess you're still muted. Anyway.
Oh, oops. Sorry. No, he was trying to spread some late-breaking news and wanted to be the first to break it, but he got found out. He wasn't the original source, and the original source may not be reliable. Which leads to... Yeah. Do you love my segues? Aren't they great?
I think this is just like, you know, yeah, they're great. You know, they're far better than a train wreck, and I'm kidding, of course.
Okay, well, do it yourself. That's all right.
No.
Question for chat, and Keith, if you could take this over to your channel. Like Mark was saying, down at Devil's Tower, the UK Sun was there.
Yeah.
I see. When you said that, I thought they were a reliable paper. Now I'm hearing they're a bit of a tabloid. What exactly did they do with your article, Mark? Can you tell us about the article for those who haven't read it?
Yeah. I relayed a story that I from an experience I had on board a nuclear sub that I had the pleasure of being a guest on, because I did some work for the Navy, and they said, "Want to go for a ride?" I said, "Sure." And going for the ride, I saw in the sonar area, and it became a big hullabaloo on board the boat, when the sonar operators saw something moving underwater that was moving at a very, very, unknown speed, you know, and that is to say a speed that we could not achieve. He called the executive officer over, and the executive officer looked and said, "Wow, that's something. How fast is it going?" And the kid said, you know, several hundred knots. And he was like, incredulous by that. Now, that is to say, the kid was incredulous, and the executive officer, the XO, he just said, "All right, log it and dog it." That's the short summary of everything. And so I relayed that story, and the Sun picked that up and wrote an article about me and that whole that whole event that transpired on the sub. So that article, was written by a reporter named Emma Perry, and she actually only put what I told her, and she left out the things I told her not to say. She did it. She did exactly what I asked. So I was very impressed with that. So yes, it's known as a tabloid, but they actually got some of this right. They got that right. And so some things are actually newsworthy items, or some of these items are actually, told right. And they told this right. So, but that's what happened there. So that's the story that got out and about. And I wasn't the only one they wrote stories about. Actually, all the speakers, they released them. They released stories, slow but sure, on each of the speakers that were there over time, and it was nice. They did a very nice job.
And that article caught a lot of eyes. A lot of people read it, including our good buddy Tyler.
Oh yeah, well, yeah.
Down at Secure Team. What is it? Glockner?
Yeah. Secure Team.
Tyler Glockner.
Secure Team picked up the article, and I don't give them credit much. However, he relayed the article without any exaggeration or embellishment. He just relayed it just as it was written. So I thought that was more honorable than I give them credit for typically, because most of the time they're just promoting absolute garbage, But then Tyler contacted me and said, Mr. D'Antonio, would you please come on for an interview on our channel? And now the question of the day is, and this is the one you're going to ask, right, Amanda? Is that what you're talking about?
I'm typing it in right now.
Whether I should actually do this interview with Secure Team. But I want to see, if I do it, all right, and this is what I need all of you in chat to help me figure this out, because I'm going to do what you say, actually. If you tell me I should do it, I'm going to do it. If you tell me I shouldn't, I won't. All right? I do have a mind of my own, and I have an idea myself, but I do want to, because I'm basically your representative in the SkyTour LiveStream, I feel that you have a say in this, and I want you to be able to suggest what you think might be the best course of action.
Well, that's what I said. I not just, it would be hilarious. Why or why not? Because there are pros and cons, and that's kind of what we're looking for.
I could actually do the interview on my channel, on the SkyTour LiveStream. I can actually do it as have him come on as my guest in the SkyTour LiveStream and do the interview here.
That would give him so much credibility.
Well, that's
but if he keeps putting out videos like that, I mean,
I don't mind
but
changing his history if he wants to.
They do have a following, which could help you. So
yes, I mean, consider how many people he has. He has how many people?
I don't know.
Yeah,
I don't know, but
an ungodly number of people. Well, that's good. To his credit, he does. And what that shows me is, on one case, this is what we have to fight against. Okay, the garbage. Okay, but on the other hand, it shows me how hungry people are to find the answers. See?
Well, can't someone just maybe you actually granting this interview could change his mind? Because that's what I said. Like, people like weird stuff on the internet. I mean, they like seeing things they can't explain. It would be so easy to say, I caught something passing by the moon. Here's the time. Here's the clip. What do you guys think it is? And then let the chat discuss it. Don't say, we caught a UFO. Look, we caught a UFO. Look, we caught a UFO. And everyone's, no, it's never a UFO. Just say, I don't know what it is. And let chat, and if no one can figure it out, then follow a story. Say, okay, next step, let's send it to a professional that can figure out what it is. Let's do some extra work on it. Like, make it a team thing. If you want to put out those videos, you know, people are still going to watch because you don't know what it is.
Yeah.
But don't always label it UFO. Like, that's why people are staying away from the name UFO lately. Because you hear that and you dismiss it right away. So, you know,
Well,
I know that. I mean, he's doing something right to have that many subs. He's doing something right to be writing and editing, like, you know. But I don't know.
But as such, we're actually, you know, we're changing the name, for instance, of UFOTOG 2. From UFOTOG 2, we're changing it to Aerial Anomaly Detection System. And we're doing that because we want to get rid of the stigma of UFO. And thus, it'll open the way for people who are in the scientific community to actually participate with us and not feel, oh, battery exhausted, and not feel that there's, you know, some kind of you know, stigma associated with it. You know what I mean? And that's something that we're looking to do. You know, that's something we're trying to get to, is that. And that, you know, by changing the name, I think it's going to work for us. And it doesn't mean I'm selling out to a scientific crowd or whatever. I want to actually get science involved in this. I want science to be able to,
Ooh, holy cow.
I know, sorry about
Watch your eyes.
that. Hang on, I got a spider crawling on me here.
Ooh, oh my god. That's even scarier than the light.
Hardly.
Daryl wants to know, could that affect your clearance or military work? Great question. I never considered that.
Oh, I did. I mean, and I do. I mean, I consider it from day one, you know. I have to work on that stuff.
Well, I mean, that's what I was thinking. It's going to hurt your credibility, and which is why I feel so bad, because I was trying to help a friend. I wasn't really considering it from your point of view.
Oh, I mean,
but I actually, with that Flat Earth interview.
Yeah, I don't
But,
think,
when I get depressed, you know I'm going to bring up the Flat Earth interview.
I don't think that people realize that you had done any of that, you know.
Well, it was like I saw an interview with Richard Dawkins, and he was saying when these, you know, Christians want to battle atheists, it's like, because you are talking to a big name and a respected name, it somehow gives you credence that they took the time to bother with you. And that's my biggest dread. That's why it's like, don't pander to them because they're ridiculous. You know, and I don't want it to hurt your credibility or any of the work you're doing, you know, because, and God forbid, you attract trolls from there to here.
Yeah,
because you know he's going to bring a troll army, and I don't think we have enough mods. Speaking of which, Dee's in the house.
Hey, Dee. Thanks for joining us, and I want to thank everybody, too, for coming along. Cause
yeah, there's tons of people, but I see some people that possibly should have wrenches. See, Mark has a million things going on. He's not actually at chat. That's why I'm here, and I can't, unfortunately, control who gets modded and who doesn't. Like, I don't have that option. As a mod.
How do I give you that option? Can I do that?
I don't think you can. I think only you can mod people because you're the creator. Well, like, it's your channel, you know what I mean?
All right, well,
we'll look into that later. We'll look into that later.
A lot of people I would love to have as mods that, you know.
I think maybe if they're subbed, you can go and mod them that way. I think.
I think you're right.
I'm not 100% sure. Like I said, we'll look into it later.
I did it with Keith one night.
Oh, there you go.
Wow. Well, this is, I can't believe it. We've been looking at the moon since it was over there in the sky, and now it's over there in the sky. And I am just chilled to the bone. I'm starting to shiver. So I hope you guys don't mind if I go in and get warm. You know, I don't want to leave you hanging here, but I'm definitely...
Keith just said the results from the poll on his chat so far, 6 people say yes, and 1 says no.
Okay.
Duplicat is in here, he says no. Yeah, Daryl asked about it hurting your military work. Do you suggest if it's recorded by a third party? I mean, I wouldn't have a problem if you wanted to stream it on my channel. I'd have both of you on. If you wanted a third party, I mean, Mark's gonna do it live. It's not like he's gonna edit it. I would be worried if Tyler would do the same thing.
Well, that's the thing. That's why I want to do it on my channel, because if I do it at all, by doing it on my channel, I have control over the final version. He can also get a copy, and he can take and edit it any way he likes. But I will always have the last say as to what it was, because this is the actual, and and he may not want to change it. I mean, I have to tell you, I mean, he's been very respectful to me, and maybe that's because he knows that I'm, I don't take baloney, I don't take crap and stuff like that from this. So maybe he's being respectful for that reason, and if so, that's good. He should be, and he is. So we'll see what happens. But I want to hear what everyone says, because as I said, you have a say in this, because I'm your representative here at the SkyTour. So I want to make sure that I say and do the kinds of things that you would expect me to do, and be good about it.
Yeah. Well, I don't know. Pro voted yes. Keith said that he talked to you about this offline.
Yeah.
I mean, that's the thing. I mean, it's very easy to say, yes, you're going to mop the floor with them, blah, 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 but it's not going to be. It's not going to be like, it's not going to be a put-down competition. It's not going to be,
not at all. I mean,
a yelling match.
It's basically science versus speculation.
Because anything he asks you, no matter where he goes, you're going to use the facts, and you're going to use science, and you're going to be telling the truth. So I mean, really, unless, like we suggested, unless he wants to do something underhanded and edit it to his liking, but with your full original, then he'd just be caught out. Like, there's really, I can't see anything he can do to really, and then who knows, maybe this would be a turning point for him, and I don't know.
Yeah,
I'm trying to be an optimist here, but
I get it, yeah.
But again, we have to think of your best interest too, and keep you safe from trolls.
Well, I appreciate that. I really do. Hopefully you guys, I get a fairly good answer from you here in a minute or so, but I'm going to be signing off here pretty quick. As Keith says, we're going to wrap for the night. Well, I'm going to wrap for the night and then go
wrap into a blanket.
Exactly so. I'm going to wrap up into a blanket. So I want to thank you all for coming, and I really appreciate it. You guys are great. I love your company each night, and I want you to know that I really appreciate your efforts. Thank you for coming. Make sure you subscribe and get your friends to subscribe. Pass along the word. I will be happy to answer questions through the video in the comments if you like. And at some point in the future, I'm going to give you my email address too, so you can email me. Don't forget, we're going to be offering these craters for people who might want them. Just name your favorite crater, and we'll see if we can arrange it for you. We'll have full pricing in the coming weeks, and it'll be spectacular pieces of the Moon, Mars, Pluto, Ceres, Vesta, even the Earth. But if you guys are interested, let me know and tell me what you think of it. Also, visit FX Models Planetary Replica Division on Facebook and see them live. See them there. I sent those pictures today. So I will talk to you tomorrow when I can actually recover. Thanks, guys, for coming. I really appreciate it. Good night, all. Keep looking up.